Nice to see you all.
Thanks, Karen.
Yeah.
Well, welcome everybody. Thanks for all coming in person. A great turnout today for our final council meeting of 2023. Just a little housekeeping issues and things to talk about before we get started. This is normally where I would do a land and territory and water acknowledgement, and my goal behind doing that at the council meetings in the past has been to really normalize the discussion and the discomfort associated with government-sponsored oppression of Native peoples. It has been brought up by council members and some others that this could be kind of viewed as a box checking exercise, especially if the council isn't doing active work towards undoing some of those actions and programs in place and trying to improve the equity amongst indigenous peoples. There is work being done, and we'll hear about it at the end on the safety work group. But what I'm going to do now is kind of engage with our equity work group and talk with some other contacts to kind of revisit the acknowledgement and the practice and kind of go from there in the future. But there are some resources here if you're interested in learning about the lands that you live on. In Sacramento, it's the Miwok, the Nishan and Patton peoples that we live on. But I encourage you to check out nativeland.ca for information on historic land. Again, so housekeeping, the meeting is being recorded, so go ahead and mute our mics. We have kind of a global mic here, but recognize whatever you're saying here is being recorded. But if you're online, like Jared, if you can mute yourself, or Lori, unless you're speaking, that'll be helpful for recording. I'm going to do a roll call for the members in the room and then on online. And if you're a non-council member, just please put your name and affiliation in the chat, and they'll have that for recording purposes. So with that, I'll start with the roll call. Callie Pierre, our chair.
Hi, yeah, I'm Karen Mogus, Deputy Director, Division of Water Quality at the State Board, and I'm the co-chair representing Cali, PA.
Okay. Natural Resources Agency.
Caitlin Kalua, alternate for California Natural Resources Agency, Deputy Director of Ocean Protection Council, sitting on behalf of Jen Eckerly today.
We'll just go around the room this way.
Krista Kamer, CSU Council of Ocean Affairs, Science and Technology, known as COAST, scientific community academic.
This made it look.
If people online, can you please mute your mics? Go ahead, Ray.
Ray Heimstra, Associate Director at Orange County Housekeeping, and I'm the public member of the council.
Hi, Steve Weisberg, Executive Director here at SQUIRP, and I am the non-academic scientific community representative.
Thank you, Steve. Thank you for hosting.
I'm Peter Vroom, Deputy Director, City of San Diego Public Utilities, and I represent the Water Supply Sector.
Hi, Sam Choi. I'm the manager for Orange County Sanitation District. I'm the alternate representing the POTW sector.
I'll go. My name is Dick Martirano. He and pronouns. I'm the director for the Water Quality Monitoring Council.
Hey, good morning, everyone. Grant Sharp of the Orange County Public Works, representing the regulated stormwater community.
Mark Cady, California Department of Food and Agriculture, representing agriculture.
Great, thanks. And for the council members online, let's go ahead and start with public health. See Anthony on there.
Hi, yes, Anthony Chu, the Division Chief for the Division of Radiation Safety and Environmental Management, representing California Department of Public Health.
Thanks, Anthony. Okay, let's go with Helen and the citizen monitoring. Helen. Might be muted. All right, we'll come back to Helen. All right, Lorian.
Good morning, everybody. Lorian Fono, representing the regulated POTW communities.
Helen, do you have your? Well, Helen Patanides is there. She is. Go ahead.
Hi there, Helen Patanides with Sierra Streams Institute, representing community monitoring groups. Sorry, I'm having a hard time hearing everyone.
Is anybody else having experiencing issues hearing online? Oh, well, not. Okay, well, with that, I'll go ahead and go to the agenda review. As you are aware, I've kind of circulated the agenda previously to the council members and workgroup co-chairs. This meeting is focused on the topic of plastics and microplastics monitoring, going through kind of the state, the big picture of where we are, where we're monitoring, the methods we're using for monitoring, whether that be in the field, in the lab, data collection. We'll also hear from our safety work group. Are there any changes proposed to the agenda? I have none. Seeing none, and we'll just go with the flow. I've circulated the action items. There weren't very many there. Those are final because there were no comments received. Okay, this is the opportunity for a public forum. So anybody, any members from the public that are either in the room or online that wish to speak to the council on topics that are not on the agenda, this would be an opportunity for you to do so. So if you're in the room, raise your hand, and if you're online, raise your hand, and we'll get you acknowledged. Anybody have a public forum topic to talk about? Seeing none, we'll move on. Okay, item 3, member and director updates. I'll start off with folks in the room, and then followed by those that are virtual council members with any updates. And then there's a special item on a subcommittee that we'll have a few slides on, and following that, and then I'll give my update. So let's go ahead and start with Grant. Do you have any updates?
Yes, thanks, Nick. Just one quick plug for an upcoming California Stormwater Quality Association seminar that will be held on January 25th. It will be virtual. That's 10 a.m. to 3 p.m. And typically CASQA, with their January seminar, they like to do kind of a regulatory update. They invite members of state water board, regional water boards from around the state, as well as EPA to join and provide updates. And looking at the agenda, Karen, looks like you were on the agenda, and we'll be talking about state water board the year ahead. And looks like there are invites out to a number of other regional water board executive officers, as well as invites to US EPA representatives. So should be a good meeting, and you can register at the CASQA website and participate online. That's it from me, Nick.
Thanks, Grant. Mark?
Just a plug for groundwater protection. And CDFA has currently has an RFP out for grants for the State Water Efficiency Enhancement Program, which is for farmers to improve irrigation systems to make them more efficient, which of course protects groundwater. And that's at $21 million this year. And it's a roller coaster because it's been higher and it's been way lower, but it's been going on for a number of years. And I think it's improved groundwater, at least the potential for groundwater quality as it moves through the Beto. So.
Thanks, Mark. Can you share that link with me, or the RFP when you get a chance? Thanks.
I don't think I have any updates. Big updates is OPC is working on an updated sea level rise guidance. Essentially, our current guidance is a 2018 document that guides sea level rise productions and planning for a number of different uses. This is something that OPC is committed to updating every 5 years. Anticipating momentary public release, it'll have a 45-day public comment period, anticipated to be then brought before our council at our February 29th meeting. So those that are interested, certainly that intersection of infrastructure and other impacts of sea level rise, it's very notable. Another just for just awareness, Cali PA, CNRA, California Environmental Protection Agency, as well as the Natural Resources Agency, in partnership with the Office of Environmental Health Hazards Assessment, so OEHA, trying not to get out of that alphabet soup a little bit, is hosting a climate change symposium January 24th. So Nick, I believe it's publicly shared. I can share a link, but that will be looking at climate change indicators across environmental and human health. It'll be a symposium starting January 24th, but then a series of webinars throughout the first 6 months of 2024. So a number of topics that certainly are cross-cutting.
Is that virtual or in person?
I believe there's hybrid options.
I did think of an update.
Okay.
As I don't remember which council meeting this was, but recently we had Lori Weber come and talk about the integrated report as one of the initial reasons why the council was formed. And just wanted to let you all know that the 2024 integrated report is about to go out for the final 30-day public comment period in the beginning of January. And will go before the state board for review and adoption on February 6th. And I'll just say that it's the second time in all of time that we've been on time.
It's a miracle what an extra unit can do. Chris, do you want to talk about something maybe besides?
Actually, I got an email from Casqua. Am I saying it right?
Sure.
About these different pieces of legislation that are moving through the Assembly and the Senate for a climate bond in the fall. So I'd encourage everyone to kind of pay attention to that. There are 4.1 billion, I think, and lots of different ways to be allocated. So it's something that wasn't on my radar until last week. Some of you are not, so I already know. But a lot of money pouring in, especially in a bad budget year. That's it.
Great, thanks.
So Nick, we struggled with the role of the council on some of the things like bond acts in the past. Obviously, some individuals like you are limited in your ability to communicate with the legislature and stuff like that. There's a bus going on. And so we kind of struggle as a council as to whether or not we should develop kind of a council position or a set of recommendations on these things, which would then be communicated obviously by people who are allowed to communicate. I think that would be a great subject for us to talk about in a future meeting, right? Because it will take a while for this bond stuff to happen. I think one of the things that we do as a council is develop recommendations for what some of the biggest needs are. And I can see us being an effective entity to communicate. Fine line between advocating for things and essentially helping them better understand some of the things we've already experienced.
Ray, do you have any updates?
Yeah, actually at the California Coastkeeper Alliance retreat.
Hold on a second.
Just brought up AB 1066, which is for those of you that may not remember, that tasked the council with developing monitoring criteria and sites for inland waters, but it provided no funding. So I asked Nick for an update on that, and he reminded me that we looked into it, but it was an unfunded mandate. We don't have any funding. So I said that I would, try to work on that. And I think related to what Steve said is that, the council itself can't really do it, but some of us can advocate for, if you're going to ask for something. And I think that's really important. There needs to be some funding. So I'm going to, I just think maybe that's something we can kind of put on our radar for 2024. I'm not sure exactly how to even tackle that, but I want to tackle that.
Okay, thanks, Ray. Steve, any updates?
Two that are related. About a month ago, I received funding ultimately from NOAA to help develop a West Coast Ocean Health Report Card. Simultaneously, or nearly simultaneously, actually yesterday, the Ocean Protection Council awarded funds to the California Ocean Science Trust to develop a report card. These will be, hopefully, they've been planned as joint activities. But I think that's something the council may want to pay attention to because, maybe Kayla could speak a little bit more about how they're planning to use it. But I think this will be a big deal. And having the insights of something like the council, particularly the multiple agencies that serve on council, and kind of reviewing or suggesting ways that this can move forward. I think that could be a great topic for a future. I think you heard probably a year or two ago some of the initial West Coast Ocean Alliance efforts kind of, but I think it's turned now from something that was conceptual to now it's about the rubber's about to hit the road.
Great.
And I'll add, so California's effort, the West Coast Ocean Alliance effort is certainly West Coast wide, the entire California current. OPC is funding the California specific portion of that in partnership with Ocean Science Trust. Develop essentially, it's a 2-year effort for a 2025, end of 2025 report card through scientifically defensible ocean health indicators, kind of getting our arms around what is a comparable quality state of our data on a various number of topics. So it's pretty large lift that the Ocean Science Trust will be convening through a task force. So I'm pausing as far as timing, maybe more of a 2025 item because it's just going to be hitting the road as far as having very targeted conversations. That also ties then to the OEHA climate indicator development that I mentioned as well. So there's a lot of simultaneous moving parts, but the ultimate goal of this 2025 report card is also then informing what are our monitoring needs, where can we best invest, what are the gaps, as well as, where is there consensus as well. So that'll be very ripe in 2025.
Great.
Not all the indicators, of course, are water quality, but I guess that probably half are pretty darn specific to the things that council deals with.
Great. Anything else? No. Peter?
There have been several working group meetings over the past few months, particularly as far as the safety work group and the bioaccumulation monitoring program realignment goes. And I wanted to give a shout out to Anna because I have a feeling there's a lot of frustrations with chairing those groups and you're doing a fantastic job. Just based on what I can see. So I just wanted to say thank you. As far as the Safe to Eat work group goes, the meetings had a variety of informational items and also some discussion as far as monitoring priorities for the upcoming year. I'm sure that Anna would be happy to fill anybody in. And then the other thing I want to bring up is the equity working group. For the upcoming spring meeting, we have Kim Desmond providing a presentation, and she is the Chief of Race and Equity for the City of San Diego. We're really excited to be able to hear her speak, and so I think it's going to be a really good working group for all those who would be interested in attending. So yeah, that's it.
Great. Sam, do you have any updates? No updates. Okay, great. We'll move on to our online members, and my Zoom keeps on getting shut down, but I'll go ahead and start with Andrew Altivote, who I missed on the participant list previously. So can you please introduce yourself and your role in the council and provide any updates, Andrew?
Oh, sure. Hey, Nick. Yeah, Andrew Altivote with the Division of Drinking Water at the State Water Board representing drinking water, and I actually don't have any updates today. Thank you.
Thanks, Andrew. Lorian, do you have any updates?
Yeah, sure. I just wanted to quickly note that the independent peer review that's being hosted by NWRI for the SCORP OAH from spec model on ocean acidification and hypoxia, that's kicked off. And I know that we had discussed tying in a discussion about monitoring data to the model needs. So I'm looking forward to potentially doing that in a future meeting and having that be informed by the results of this peer review.
Great. Thanks, Lauren. Anthony, do you have any updates?
Hi, Nick. No, I do not have any update at this time. Thank you.
Thanks. Ellen, do you have any updates?
No updates really. I'm just excited to be part of the subcommittee on fire effects on water quality.
Talk about that next, a little foreshadowing. Fred Briones, our alternate for the public. Fred, do you have anything, any updates?
Hello, hi.
Hi.
This is Fred Briones. Yeah, sure. I'd like to share one thing with the group that recently for SB 54, the Plastic Pollution and Prevention Law. I was nominated by the governor to be on the advisory board. That new SB 54 law will raise $5 billion from the plastic industry and will, in 2027, over a period of 10 years, will administer that money to disadvantaged communities, which I'm the representative for. So we'll see how that turns out in 2027. So that is my update. Thank you.
Thanks, Fred. Congratulations. Okay. With that, we will turn it over to Krista for an update on subcommittee on fire effects on water quality, which overlaps with a little bit of the discussion we were talking about funding.
Thanks, Nick. So some of you may remember that in May of 2022, we convened it was a virtual panel of a group of researchers from around the California State University who are working on various things related to post-fire water quality impacts. And so since then, it's been a year and a half, I guess, but Steve Blumenshine, he's not here today. He's the alternate scientific community academic member, and he has been a faculty member at Fresno State for over 20 years. And he is now the executive director of what's called CSU Water. So within the CSU, it's so large, we have these sort of thematic groups. So I'm coastal and ocean marine water quality and research, and he's more water resources, drinking water, a lot of inland valley groundwater, Central Valley groundwater stuff. So we've been working together since then, along with Nick, and talking about a subcommittee. So if you go to the next slide, Nick. So, we know certain things about the impacts of fire on water quality through a number of different processes. And I guess to me, one of the things that's really interesting is that we're having more and more of these fires at the wildland urban interface. Like we had the campfire, like in Lahaina. And so there's all different kinds of stuff going on than maybe you would get from a fire on strictly wild lands where there's no human structures. Okay, I guess part of the slide is missing there. Anyway, so what we don't really have though is any kind of statewide monitoring plan to assess some of these post-fire water quality impacts and then the pre-fire data to compare them to. So if you go to the next slide, we're proposing that there be a council subcommittee that really focuses on the effects of both the wildfires and, like I said, the fires at this wildland urban interface and the impacts on surface and groundwater water quality. And so the subcommittee would be made up of members from the council, and the subcommittee would be charged with then engaging experts from other sectors to form a team that represents a broad array of stakeholders. And part of this that's really important, and I think a lot of the state agencies now do this too, is that it's really important that we have folks from all different aspects of society, including people who have not often been at the table when developing resource management policies and decision-making. And our vision that Steve and I have and have discussed with Nick is that the subcommittee would facilitate the development of a white paper written by this group of experts that we would help assemble that would review the existing knowledge that we have, identify where the gaps are, and hopefully eventually propose a framework for a statewide monitoring plan. Of course, would be money down the road, right? And that along the way, we would certainly keep the council informed and determine the next steps. And that goes back to what Steve was mentioning before about how the council interacts, or how council members officially interact with the state legislature, for example, and where's the line between raising awareness and giving people access to the best scientific information versus advocacy. So if we go to the next slide, I'm gonna be, folks on board doesn't mean like on a board, it means people who are like on board with the effort, right? So the folks on board are me, Steve Blumenshine, who I mentioned, and we've done a little initial outreach specifically to Helen Fatanides and Fred Briones, who are here today online. And I want to thank both of them for being willing to just jump right in and dedicate their time to this. Greg Gearhart's not here today, but we met with him separately and he was also interested in this effort. And so this is an invitation to anyone else who's here who wants to participate. So just let me know, either here today or email me, and then we'll get started. So thank you.
So I'm curious, why a subcommittee of the council members and not a working group like we have for the other
Oh,
topic
well,
areas?
we talked about that, and I'm gonna let Nick explain.
Okay.
Yeah, so I mean, the subcommittee seemed to make sense to develop kind of the initial white paper and recommendations and to raise awareness. Forming a work group around fire monitoring is a little bit difficult when the main issue is that there isn't many people doing fire monitoring. And so to develop a work group around an issue that doesn't exist really, like there's nobody doing it, like who would sit on a work group when they say we're not working on this. That being said, if there were an outcome that led to either funding or a more cohesive avenue for fire monitoring, then certainly we could develop a work group to talk about methods, development, data management, and everything that goes around monitoring. But at this time, it seemed more manageable to start with a subcommittee and just really make awareness of the problem and the data gaps that exist. And after talking with Craig and some of the efforts that the water boards have had trying to get a pre and post fire monitoring effort moving, and it just seemed like the best route to start with was a subcommittee and come up with some consistent recommendations from the experts and raise awareness prior to developing a work group, because we really didn't know who would even populate that work group.
That makes sense. So something to be decided in the future then.
Yeah.
Great.
Yeah, so this is an initial step, see where it goes, right?
Cool. Yeah, I think it's good stuff.
Yeah, and again, if you're interested in joining the subcommittee, it's got quite a few members already on it, so there's no necessary need to, but we wanted to be inclusive. And I think that's part of the intention here is open it up to other council members that may be interested in specifically post-fire monitoring or pre-fire monitoring. And while this might be a one-off type of subcommittee focused on fire monitoring, I think that the recommendations and maybe the strategies that are developed to kind of think out of the box as far as engaging different audiences, whether that be through brown bags, through reaching out to specific groups of people like legislative staff to raise awareness, or other groups, just to say, we're not making any recommendations necessarily or advocate for anything, but here's the issue. You come to your own conclusions, like here are the data gaps, is where we can really gain from making better decisions by having this data or having more consistent monitoring data. Then they can kind of move the ball from there if they would like to.
I add too, if we wanted to do anything like a brown bag lunch, we don't have to go do that ourselves. So CSU is now a partner in something called, it's like this Nexus thing. It's at the California Research Bureau, which is I think in the state library. If anyone knows and I make a mistake, please let me know. But so we've been working with this new program within the California Research Bureau. They convene events that feature a number of experts. There's also the Center for California Studies. They convene events and brown bag lunches and stuff. So there's lots of opportunities to work with other groups that already know the audience and have the infrastructure for advertising and can put events on like that. I think they're always looking for topics. They're always looking for experts. So it's not something that we would have to go create, get partner with other people who are already doing.
That's a great point. And I think what I was trying to iterate was that the strategy developed with this group on post-fire monitoring could then say another group of council members were interested in another type of specific monitoring, whether that be OH or plastics, we're talking about plastics, then that could potentially be create another subcommittee that's focused on leveraging those strategies that were developed by this group and utilize it in other avenues for other monitoring types. So there is some potential applicability beyond post-fire monitoring and just fire monitoring. Thanks, Crystal.
Thank you.
My update. So I've been working with Krista and Steve on this subcommittee topic, which has been great. I also got a chance to attend the Coast annual symposium, and that was really great. It was over in Long Beach. Got to meet a lot of really cool faculty members and students that were there, and followed up with a couple of them. Some of their epic work was really interesting on how to engage better with different communities and engage with students, which I think is a really great opportunity to make up for some of our resource deficits at the state and leveraging student and faculty work and their monitoring work with our own. Another big thing that I'm working on is the My Water Quality web pages with the work groups. So I've brought it up probably a year ago now that the Department of Information Technology has a web support team, and they were willing to dedicate resources to create a new set of My Water Quality web pages. Our template that we're using is decades old, and so they have two guys that are helping develop these new web pages with a new template. We're making some good progress there. We've got the Safe to Eat work group. We've got the Healthy Water Systems Partnership, so environmental flows, wetlands, estuaries. They're all got either a mock-up version ready or a template that's in the queue to be developed. We're hoping to get the other work groups on board and have something submitted by February. And if not, it may be that we just push the existing templates from the work groups out to the new web pages, and then as work groups find time to prioritize the website, move them into the system, just so that the work groups that have worked actively to develop this new look and feel can be honored at the time they spent on it. It is really cool. Like, unfortunately, I can't send it anybody outside of our water board's VPN access to share the mock-ups, but maybe at a future meeting, or if somebody's interested in kind of seeing the look and feel, I can certainly just do a demo of what that looks like at a future meeting, or anytime, just reach out. It looks a lot like the Santa Monica Bay Restoration Commission's website, but it mimics that kind of look and feel. So it really allows for better engagement and cleans up a lot of the information that's been kind of just compiling over the years on the My Water Quality website. So it really lets the work groups kind of dive in and glean kind of the old stuff and focus on the current stuff, and make a much more interactive way for outside work group members to engage with the information that we're putting together. Another big project that I've been working on is the Water Board's Racial Equity Data Action Plan, which was built off of the Water Board's Racial Equity Action Plan, which is building off the Racial Equity Resolution. And what in the Racial Equity Action Plan, it asks or directs OEMA to develop a Racial Equity Data Action Plan, and it consists of several elements, including a cataloging of what existing tools are there, as well as developing training and guidance on how to best utilize the racial equity data that is available to look at things like demographics and impacts of our programs on specific communities. And so I've been working a lot with some folks at our Office of Public Participation and some volunteers across the water boards to try to develop this guidance. It's a heavy lift, and it's not any of our full-time jobs to work on this. So it's a little bit here, a little bit there, but trying to come together so that we can be, as the rest of the actions really direct our programs themselves to start reporting on how our programs are impacting specific communities, or how the things that we're changing, like the realignment, how are we improving on how we engage? Are we really looking at how we do our investigations or our enforcement actions on our permitting? Are they done with a racial equity lens, and are we building that along with other topics like workforce diversity? So it's been a big chunk of time that I've been working on, which has been slow moving, but I'm looking forward to it. We just saw that we might get some coaching from some outside help on this topic, since none of the people at the water boards necessarily have this in their back pocket as a skill set. Another thing that I sit on the steering committee co-chair on the Water Data Consortium. So it's been a chunk of time kind of developing how the data consortium now that's developed and has a plan in place, how we move from planning mode into action mode. It's been really positive. They're looking at maybe doing it at the data symposium next year at some point, and working with them as a kind of a go-between on the open data aspect. So while we're focused mostly on the collection and communication of data, this is more about how do we publicize the data in an open way so others can use it more effectively. And the consortium is kind of a go-between between the state agencies who don't always communicate the best. So the consortium is there as an independent kind of entity to help bridge that gap and develop recommendations. And they've got some really cool reports that have been coming out on how to best engage and how to develop protocols that are consistent across the agencies. And then lastly, that's not on this list, but I've been working with DWQ staff, the Division of Water Quality staff, on the follow-up bacteria summit meeting, which I think will probably be sometime in late summer, early fall, early mid-fall next year. And it's going to follow up from the bacteria event that occurred 2021, right? 2022,
Last fall.
last fall.
A year ago.
Okay, a year ago. So we're following up with that, with the focus on and kind of engaging with the communities that weren't there at that first meeting, particularly the environmental groups and tribal representatives in other communities. And we've developed the leadership of Rebecca Fitzgerald, a planning committee that includes tribal representatives, folks from the environmental community, Gila Bay, RDC, as well as the regulated community and ourselves to help develop a follow-up event that's going to be about 2 days, similar type of format where we talk about items that are important to that specific community to move the kind of communication forward and develop potential prioritization around specifically bacteria monitoring elements. So working on that as well. Any questions for me? Yeah.
Yeah, what's the timeline potentially for that?
We're looking at the event to be likely in fall of 2024. So we're working almost all this year, just trying to get that planning development. We had aspirations trying to do this year, but it's being cleared to do the proper outreach, especially with tribes and other underserved communities, get their voice and get their time to get their voice included. That took a lot longer, a lot more thoughtful engagement, which is to be expected. So that's why it's taking a little longer. But I think in the end, that'll create a better, more inclusive event. There'll be more on that. I'll report back when dates are firm. There's a bunch of dates thrown out there to see what works out for the majority of people. Any other questions for me? Yeah.
Yeah, question for you, Nick. In the past, I know the council has sponsored data science symposium events, I think in June timeframe. Any plans to do a symposium this June?
That's a great question. No, and that's primarily because it was a big effort for our Office of Information Management Analysis, which is a really small office, 25, 30 folks, and it was a big lift that was just something that we couldn't maintain. Similar to the Water Data Challenge, which is another thing where we lost kind of partnerships there. That being said, I think the Water Data Consortium as being kind of a third party partner where they can kind of leverage some outside resources. We were looking at potentially having a data focused consortium, or not consortium, type of symposium that could be similar and allow for spreading the wealth of the responsibility for planning it. So having multiple state agencies involved with providing resources and helping develop it. So it's a little bit less intensive on our smaller office to put it together. And I think it'd be more inclusive as well and bring in some other perspectives rather than us really talking about things to ourselves. So no on the symposium from the water boards kind of sponsored, which we really dedicated my time primarily, which is what that meant, but they also included a lot of the work groups that work they're doing. However, we're still looking at having more public engagement events and publicizing the great work that the work groups are doing and the council is doing. So, and I sit on the National Water Quality Monitoring Council too, and it's a big part of their national conference and their toting the work of the California Water Quality Council there. So while the event may have changed, I think we're just looking at other opportunities and ways to have a better set of agencies participating. So yeah. Thank you. Yeah. With that, almost on time. Who would have thought? Next up, we have Scott and Caitlin. Do you want the clicker? You want to come and stand up and present? Yeah. Finally diving into the topic of the day. Thanks again for coming in person. Appreciate it.
This is great.
Serving us out.
Here we go. Cool. Hey, everyone. I'm Dr. Scott Coffin, scientist with the State Water Board and the Drinking Water, and I'm presenting here with Caitlin
A Deputy Director for the Ocean Protection Council, and I do just want to have a really quick plug. just how thrilled I am with today's topic. I'm so excited when Nick reached out for the microplastics topic today. Not only for the big picture of what's happening for the microplastics strategy for California, development of a future monitoring, coordinated monitoring plan, but also a number of projects that are on the agenda today are in part or entirely OPC funded as well, that are all feeding into the implementation of our microplastic strategy, as well as then tie into this overarching statewide monitoring plan. So for me, it's like very, very good. So thank you all for being here.
Yeah, I love the excitement. Cool, so I'm gonna provide a sort of the overview for the rest of the day of really like, how did we get here? Where are we going? Where are we now? And I would be remiss to not mention where we started in California with this plastic pollution issue, with Captain Charlie Moore discovering the Great Pacific Garbage Patch between Hawaii and California, incidentally on a 1997 Trans-Pacific sailing race. This was really the first time that the media found out about the plastic pollution issue and really raised the alarm for California and the world. And so since then, where are we now in terms of the issue? Unfortunately, we are currently exponentially increasing the amount of plastic that enters the environment. And relative to about 1997, we're approximately putting about 4 times as much plastic into the ocean every day as we did back then. So by all means, this is something that we need to address urgently and effectively. And one of the greatest issues with addressing this issue is with the plastic issue is the fact that we're dealing with things that cannot be seen with the naked eye. So once you get past the trash that's out in the ocean, it tends to break down to these smaller and smaller, infinitesimally smaller particles that just get more and more challenging to identify analytically. And because of these analytical challenges, it's caused considerable stalls in scientific progress. This is really like the bane of scientific research for microplastics analysis is the environmental monitoring component. So much so that in 2004, a seminal work from Richard Thompson's group declared, where is all the plastic? We know a bunch of synthetic fibers are entering the marine environment, but we cannot find them. We cannot account for them. We can only account for an infinitesimally small amount. And 2017, there was a great publication that came out from Coleman's lab that said, great, all is not lost. We have a budget and we can figure out how much is there and we can measure it. And so really, this is when what I saw to be hope happening in the scientific field, where we're actually gaining momentum with regards to monitoring. Since 2017, we've seen this field absolutely explode. And right now it is the hottest topic in the environmental science field globally, with about 10 publications on the topic per day. And while this seems like an absolute godsend, for a researcher, it's a bit challenging because unfortunately not all these publications are created equally. One would expect with more publications, advancement of the field, for the quality of the papers to be trending upwards. This is an assessment that I just ran last week on a literature review that we're doing here at SWIRP. And we found that the quality is actually stagnant or even declining. So unfortunately, we have a lot of studies out there, don't know what to do with them. And one could say that we are basically still lost, not in a sea of plastic, but a sea of information, good, bad, and the ugly. And this is where we can actually play a significant role as a working group, as an ecosystem of researchers connected to management. And that's where I put forth a little bit of a roadmap last year for charting the path for research regulations. And really, I identified 4 main ways that we can get to this goal of really making this emerge mature contaminant. And that's through harmonization and standards, similar but different, targeted studies, and of course, open science, making everything open and accessible. And so with this, we can move from being in a sea of papers and not really knowing what to do with them or where to go, to having something like a lighthouse or maybe even a helicopter or something that can fly by. And I know this is a weird picture because I made it using AI tools. It's not real. Thankfully. I'll hand it over to Caitlin about how this intersects with sort of the global conversation.
So it's, Scott was demonstrating the scientific, level of knowledge is absolutely exponentially increasing, but also is public awareness and, certainly leading, I think, the charge of a lot of the scientific papers and developments, but conversations are happening globally. It was just last week, it was at the COP, excuse me, I'm taking a step back, the Council of Parties. So is, again, the alphabet soup. COP28 is a UN sanctioned event where they're looking at climate change generally, but there was an entire side event and focus on plastic pollution and the power and role of subnational governments, in which the state of California, alongside Canada, the government of Quebec, essentially putting a highlight on the role of plastics, as well as the international treaty negotiations as a separate topic that are taking place and really beginning to accelerate. Just last month was the third negotiating session of the United Nations, in which a number of California scientists, California organizations were physically in attendance, looking at this, what is called a zero draft text. The state of California is actively then looking at the fourth negotiating session in Canada in April of this year. That's INC 4. Essentially, there's progress, there's momentum happening, there's public will for how do we both manage, address, and prevent plastic pollution on a global scale, essentially to develop a binding treaty by 2025. So I'd say also as scientific research is advancing, so is political will and momentum. And that said, for California, taking a step back on a more local scale, 2018 was pretty groundbreaking for microplastics in California. There were two bills that were passed. Senate Bill 1422 is not pictured on this slide. Scott Coffin will go into that in further detail, that directed the state essentially address microplastics in drinking water, but also the Ocean Protection Council, in partnership with the State Water Board and other agencies, to develop a statewide microplastic strategy by 2022. So last year, OPC did develop and then adopt the statewide microplastic strategy in consultation, in coordination with our agency partners, to chart a path forward of how do we both address this need now. There is this pollutant now in our environment, but also these unknowns and the research needs and the monitoring needs associated with microplastic pollution. First in the nation, potentially the world. There's some gray area on the international piece there. But essentially the final strategy is a two-track approach, again, emphasizing the need for simultaneous action alongside research. It's not waiting until the research is complete to take early actions that can prevent plastic pollution. Prevent the flow upstream, its source reduction, as well as intervention with microplastics into our state waters. As well as then this track to advancing science and monitoring needs to then inform what are risk thresholds, what are future management actions, into then this iterative loop, essentially, that monitoring can inform. Each of these things are connected, it's ongoing. Again, we have to take both action and advance our monitoring research needs. At the very center of all of this is monitoring. We need the physical observational data. And why is that? It's powerful. Data is powerful. It can drive policy change. It also helps us track how effective are our management actions, how effective are our investments in these, whether they be ordinances or physical capture devices in our storm drain systems. This is data from the 2018 Southern California Regional Monitoring Regional Monitoring Program data that demonstrated a decrease in plastic bags in the Southern California Bight, specifically the sharp decrease in the Santa Monica watershed between 2013 and 2018. Notably, 2016 is when the statewide plastic bag ban was physically implemented. So that showed a sharp decrease physically in this watershed. Very powerful, again, demonstrating how effective are these ordinances, how effective are these actions, what is the state and our local communities actually doing? How are we doing in managing this pollutant? So that said, taking a step back from Ocean Protection Council's role here on the Water Monitoring Council, in partnership, of course, with the State Water Board, a number of those in this room, is right now trying to put our arms around a statewide plastics monitoring plan. That is not limited to microplastics. That is both acknowledging large plastic debris that, of course, then fragments, breaks down to microplastics, as well as microplastics in the environment. Noting that we have a number of statewide and local requirements related to addressing and monitoring larger debris, trash, plastic pollution, but there is not one centralized coordinated effort to monitor for both this larger plastics and microplastic debris. A lot of different methods, a lot of different pieces that can be pulled together into a more coordinated fashion. So why do this? Essentially, right now, earlier today during our updates we received from Fred, thank you for mentioning Senate Bill 54 has a very aggressive and pretty profound source reduction targets for plastics in our source stream of our consumer products. So what is the baseline of plastics in our environment? Identifying trends about plastic contamination. Are there priority locations, priority watersheds? What are the impacts, which Scott will go into, as well as community benefits of successful trash and plastic management efforts? Again, tracking our progress and then informing those more targeted future management actions and strategies. This plan is in development. Of course, it's informed by a lot of the efforts that you're going to hear from today, including Dr. Thornton Hampton has leading our charge on our field method collection about standard operating procedures for physically collecting microplastics in the environment. We have laboratory methods, but we are missing that environmental monitoring sampling piece. So part of that consideration is what is the method availability? Where are future technologies going? How do they come into play? As well as what are reporting, data quality assurance, and actual data repository needs, knowing again, there's multiple data sources coming either from regulatory, citizen science, et cetera. So that said, we know that microplastics, plastics generally, come from multiple sources into our aquatic environment that then touch on multiple agencies and multiple agency needs that can range from air quality, depending on atmospheric deposition microplastics, to then microplastics in our drinking water. So this plastic strategy is also being developed in strong coordination with other agencies, not only OPC, the State Water Board, but ensuring that this data is complementary, our efforts are complementary, but also usable at the end of the data that actually is collected is usable for other agencies, and they actually can be informing other management actions and needs across the state of California. That's kind of my last point, is that this is a network. There's a lot of momentum both internationally and nationally to advance plastics monitoring on the large scale. For California, we're very focused on the advancing microplastics monitoring in the state of California. So we have a huge opportunity to inform monitoring both nationally, but also internationally. As we're advancing these technologies, we're serving as a policy scientific laboratory as a sort on the subnational level. That said, it ranges from certainly federal, state, our community level efforts. And that is where I'm going to pause in my mental talking points and say, starting 2024, there's going to be a large public engagement component to this. It's ensuring that are we meeting the needs of the public in the very early stages of developing this plan, as well as who is doing what, where. So getting kind of our arms around the entire community of plastics monitoring, the opportunities to essentially inform a later network. The final strategy will be finalized in 2025, again, with pretty robust community feedback in the early stage, as well as before a final draft is complete. So anticipate a lot of momentum in 2024 on this. With that, I'm more than happy and thrilled actually to pass it over to Scott, who can walk through how the individual programs and components of California's programs.
Thanks, Caitlin.
Thank you.
So I'll talk really briefly about Senate Bill 1422, and then after this item, we'll talk more specifically about what we're actually doing with this implementation. But as Caitlin mentioned, this bill came out the same year as 1263 and is more narrowly focused around tackling the microplastics and drinking water issue, with a requirement to define microplastics and then come up with a 4-year monitoring plan and what to do with that data. And there we go. As part of this effort to get standardized methods for 1442 or 1422, we also tackled more challenging matrices that we knew that we'd need to have standardized methods for 1263. So not only for drinking water, but dirty water, ocean water, fish tissue, and sediment. And this is done with 2 different spectroscopic methods, FTIR and Raman, and 26 laboratories from 7 countries. This was all coordinated by Squirt. And that a lot of those papers are still being wrapped up right now. But one of the major findings from the study is that there's a lot of different analytical methods that can get you different bits of information about these particles. And not all of them are created equally. Some are far more expensive than others. And some will provide some, certain size ranges or colors or polymers. And what we really need is an idea of how to use these methods in a complementary and strategic way. we could borrow from a framework that was developed for PFAS, per polyfluoroalkylated substances, where basically you take a broad, cheap, rapid approach, like just looking for total fluorine, and then subset some of those samples that have high fluorine signatures to look for different things that may be more, these are typically more expensive and also more confined in the parameters that you get, the data that you get. So analogous to that, we developed a tiered monitoring framework for microplastics. We're still fleshing out what our tier 1 is going to be, but ideally it'd be something that gives us some rapid information about if there is a problem or not that we need to investigate further with maybe just getting the mass of the particles like pyrolysis GCMS, and then reserving just a few samples for the more expensive, laborious spectroscopic techniques. And going even a step further, an add-on to that pyramid is something that we're developing, again, with SWIRP, as well as partners from Toronto, Manchester, SpectralWorks, Marks International, to develop a forensic fingerprinting tool, which can, using a variety of different analytical techniques, actually tell us the manufacturer of that particle. And so this can really get us a lot of cool information about the flow of these particles, fate and transport, but also getting at that accountability aspect as well. And amongst all of this, we've basically only been working on the big stuff, or what we consider as scientists to be the big stuff. When it comes to the nanoplastics, this is really where we have a lot more work to do. And we currently have a distinct methodological gap right around 5 to 1 microns. And this is something that the field is rapidly developing, again, 10 publications per day, but we still need some concerted effort, ideally connected to a management or an agency goal to standardize the methods for the sub 1 micron range. So what to do with all this monitoring data? We care about exposure because we care about risk. And in order to estimate risk for microplastics, we really had to do some original scientific research and figure out what is known about these different particles. So again, through SWIRP, we developed a human and ecological health effects workshop with the world's experts, and we tasked them with determining what the dose metrics are that predict toxicity. Is it the particle mass or the volume or the particle count? What characteristics are more important for toxicity, size, shape, polymer type? What are the adverse effects, and can we use all this information to come up with regulatory thresholds? So in a nutshell, for ecotoxicity, we had a ton of studies to work with, 167, but only 22 of them were actually used in the final assessment due to data quality issues. Like I mentioned, this field is still going through some significant growing pains with regards to quality. But with those 22 studies, we were able to derive some thresholds using species sensitivity distribution modeling after doing a little bit of data alignment and, of course, some expert review. Species sensitivity distribution, common method for risk assessors to estimate harm to a whole ecosystem based on a percentile of species being affected, typically the 5 percentile. But this is an SSD that we derived for microplastics. And so we did this not only for microplastics impacts to what we consider to be the most important or likely effect occurring, which is we consider food dilution. Basically, the particles are taking up space in the organism's gut, preventing them from getting nutrient. But a much more challenging and difficult to measure and predict impact, which is tissue translocation mediated impacts. These are more likely affecting humans as well, as the particles can be transferred over our cell membranes and accumulate in different tissues, cause inflammation and oxidative stress. So because there's a lot of uncertainty in this data, studies with different quality, we came up with a tiered management framework for these thresholds that have differing levels of uncertainty about the effects occurring. And different levels of caution. So investigative monitoring threshold, here we're taking a lot of conservative assumptions with respect to the data. And so below this threshold, we don't really expect there to be effects occurring. There's a low probability of impact. Whereas above the least stringent threshold for source control measures, we're pretty certain that effects are likely occurring. So we derived two different effect-based mechanism thresholds for these categories. We also asked our experts at the end of this, so we got these numbers, we have scientific uncertainty, technical uncertainty around these numbers, but what about the heuristics involved? What about the theoretical uncertainty that you can't see these numbers? And they replied that, well, they have pretty low to medium confidence in these thresholds because a lot of these studies are not doing things perfectly. There's still a lot of open questions in the field. And unfortunately, these thresholds are just not where we would really want them to be for consistent regulatory use. But this field is developing rapidly, studies are being published all the time, and we figured that we could get more of this data quicker and in a more harmonized, standardized way if we build some sort of platform that allows researchers to access the data as well as upload their studies. So we built the Toxicity of Microplastics Explorer app, which also allows you to build your own ecosystem and site-specific thresholds using buttons as opposed to code. This can be done really rapidly. And this is where we're currently doing what's called Tomex 2.0. We're updating this database manually with about 67 volunteers from 14 countries right now. Tomex 2.0 contains about 125 more ecotoxicity studies, bringing it up to 287. This is a gargantuan amount of data, over 12,000 data points. And we have information for many species. So this is super exciting. We're still poring over this data and seeing if we can get thresholds from this that are of higher quality and more usable for regulatory purposes. But really, this effort is mostly focused on only one of three major impacts from microplastics hazards, which are the particles themselves. So we're really ignoring a big aspect, which is the chemicals that are added to the plastics, like BPA, and pathogens that can adhere to these plastics. And so there's still more work to be done. We can't forget about the additives. 2,400 substances of concern are typically added to plastics worldwide, and only 53% of these are unregulated. So there's really a lot more work to be done with the chemical-based hazards. We're also learning, really just in the past 2 years alone, about the viruses that adhere to these particles and how it can increase the toxicity in a synergistic way. So there's way more work to be done with the hazard assessment, but as far as particle toxicity hazards, we might have a pretty good lock on it right now. We also published an article with research needs, and so we're getting the message out to the community right now of really where we need to push the field forward to get to these thresholds for regulatory use. So we were also able to apply this data in a risk characterization study to environmental monitoring data collected in the San Francisco Bay. This was done by our partners at San Francisco Estuary Institute, as well as Five Gyres, University of Toronto. And they went out and monitored microplastics using what's called a Mantitrol net here. And when you superimpose, or when you compare the concentrations in the environment to those thresholds that we developed in our working group, you can see that the majority of locations within San Francisco Bay are exceeding our conservative threshold for investigative monitoring. And almost none of the samples outside of the Bay are exceeding even the conservative threshold. So this is showing that there is some accumulation of these particles, at least in the surface waters in the Bay, and there's rapid dissolution outside of the Bay. What's not shown in that figure is the uncertainty involved in this assessment. We had to make a lot of adjustments to the data in order to make apples to apples comparisons. And what happened is that the uncertainty when it's propagated is actually quite high. So we're certain that at least 25% of those samples are exceeding our conservative threshold up to 100%. So it's relatively high uncertainty for risk assessment. And the uncertainty gets even higher when you look at these higher thresholds. Very few samples are exceeding them with confidence. And so what that means from the regulatory perspective is we simply don't have good enough thresholds and good enough monitoring data to make a determination on a 303D listing. And this is draft right now. This is going through the 2024. This is a part of the 2024 integrated report. But what we are tentatively putting these water bodies in are categories 2 and 3, 305B lists that would indicate that we have not enough information to determine beneficial use support, but there is information that indicates beneficial uses may be threatened. So basically what this is going to require is just more monitoring, and it will not require a TMDL for these water bodies with this current assessment. Something we learned from this risk characterization is that while the hazard thresholds, they're not perfect, but also the environmental monitoring data is introducing a lot of uncertainty into the risk characterization. And it's mostly coming from the fact that we're missing the fibers, small fiber particles that can get through the mesh net, and a little bit from the fact that we're looking at larger particles with these manifolds. We need to get the smaller particles. And so this led us to a sample standardization work that is happening, again, coordinated through SQUIRT. And we're doing this for ambient water, sediment, biota, and stormwater. So that leads us to getting our objectives for Senate Bill 1263 for getting baseline occurrence data and investigating the sources and pathways. A lot of that scientific work was necessary to build standardized methods and to understand what to do with that data. We know that plastics can enter surface waters through so many different routes, not just from littering, terrestrial emissions, but also from atmospheric emissions and deposition, literally raining out of the sky. Once plastics are in the marine or a freshwater environment, marine environment, they can fragment and either become buried and sedimentated or even resuspended back into the water column. They can be emitted from wastewater treatment plants, and some surface waters are used for drinking water supplies. So there could be direct human health implications. We also know from a study done in 2023 out in Rhode Island that the proximity to an urban center strongly predicts the amount of plastics, microplastics that you're going to find in that water body. So this is a really cool study where they took a lot of samples from Narragansett Bay, and they saw this very strong relationship. So it makes a lot of sense. Plastics are where the people are, and so we really need to be integrating a lot of these findings from around the world into our own approaches. And what it looks like in California is really just anecdotal evidence. This was a picture taken by Paddle Up Plastic in Alameda's Bay, just miles from here, earlier this year. Clearly, we have some waterways in California that are not doing a great job of collecting all of the plastics. So we really need to be thinking about this urban water estuarine connections. As far as atmospheric transport goes, this is something that we have huge unknowns for. We know that plastics can transport extremely long distances through the atmosphere, finding them in super remote regions like in Swiss Alps, Lake Tahoe. We see them in national parks that have virtually no people. And so this is something that we also need to investigate. And like I mentioned earlier, we need to be having fit for purpose methods. I don't expect everyone to read this right now. This was in a paper I published earlier this year, but basically we can break it down to a couple different drivers, what we're doing, why we're going monitoring, with different levels of methods that would be used. So if we want to look at the environmental health, we're going to be looking at specific areas like an ocean or an estuary to compare those thresholds to monitoring data. And the technical requirements for that, the type of methods that we're going to use, it's going to be maybe low to high. But if we want to get to something like human health, like drinking water, we're going to require much more sophisticated methods, likely more challenging methods, because we're looking for smaller particles that are relevant for human health. So that's just sort of an example there. And all of this was really included, these considerations were included in the Ocean Protection Council's strategic plan. So once we do all of this, and while we're doing all of this, we also have this requirement to go back to the legislature with source reduction strategies. And
Yeah.
I hand it back over to Caitlin to talk about that.
Just a quick jump in. Essentially, as Scott already mentioned, we already mentioned, the strategy does emphasize early plastic pollution, that plastic pollution is preventable and we need to take early action. And essentially, the ounce of prevention is worth a pound of cure. And that by focusing on our upstream mitigation efforts, such as bans, we can avoid costly and ineffective mitigation techniques as well. So that is very important to this as we continue this work. And just noting that if we continue with business as usual, we will double the rate of plastic, which enters the environment by 2030. But also, I don't know if Scott, you want to add more to this?
Oh, I mean, it's basically, we have to turn off the tap first. So
Yes.
like really focusing on downstream cleanup efforts is a bit futile when we're putting about a dump truck of plastic into the ocean every minute, right? So this is just a cheeky demonstration of what happens in Peninsula Beach every year. It's a fun festival. They clean up all the ducks.
Yeah.
But
Thank you. Perfect. I just also wanted just emphasizing Scott's point again, microplastics, nanoplastic particles are bounded. People are very illuminating this morning watching flying over the Pacific Ocean, looking at the landscape, the amount of vehicles, cars, traffic, and just understanding that a lot of these future solutions or our mitigation strategies are sector specific. And in this image here, for example, are vehicle tires that have been identified as a prevalent source of microplastics, specifically in fundamental research that was conducted in San Francisco Bay, 2017. Additional research that's happened here through Dr. Gray's lab, throughout Riverside, Southern California watersheds. And here are rubber fragments that were determined to be tire rubber particles, which are known to shed at high rates with normal wear and tear. It's physically how our tires operate. They're meant to shed, which also then means a shedding of debris and synthetic fragments into our waterways will essentially then wash from our streets into our waterways. And so what are potential solutions? Bioretention cells have been shown to be effective in removing microplastics from urban stormwater to a degree, depending on the type of design, et cetera. This is one that OPC is investing in advancing this research to help support informed decision-making in partnership with the State Water Board Storms Unit. We recently funded 2 projects to help inform the site location of green infrastructure along roadways, along urban environments, essentially to intervene with microplastics entering state waters, but also then what are the best design of the green infrastructure for microplastics specifically, understanding that if we're able to intervene with microplastics, we're also intervening with a number of other pollutants, at least at that particle size of capture. Let's see, meanwhile, in addition to vehicle tires, excuse me as I'm borrowing some slides here. We also have microfibers are also prevalent in waterways. We know in the water column there are some challenges and actual method collection within the waterways as far as the different net sizes, et cetera, but in sediment samples and others, especially near wastewater treatment plants, effluent outfalls, there are increased, at least this from the San Francisco Bay study, there were an increased concentration of textile synthetic fibers, as well as other fiber sources in the environment. And so this brings us to another potential intervention strategy is looking at our clothing systems and washing machine essentially have been shown to be, washing machine filters are one effective measure of intervening with fibers from entering our waste streams that are then too small to be filtered in by our public treatment plants. There's a number of studies, one of which is pretty foundational done in also Canada and the city of Toronto. What's that? 1 minute. Oh no. Well, I'm gonna skip over and make it go really fast to this is what I mean by. Do you mind if I get back to you?
Yeah, sure.
Thank you.
So basically, I mean, we can't just be focusing on one solution here and really have to engage all parties that are involved. So wastewater treatment plants, washing machine industry, as well as textile producers in addressing the issue. And that really goes for all of these issues. Like we need to be thinking intersector and having collaborations across different borders. Also thinking beyond just this is a waste issue, thinking really from a systems level perspective and thinking about the circular economy, which of course we mentioned earlier today, we have really robust and ambitious plan for with Senate Bill 54. But in consideration of what's the next plastic, are we replacing this with better or worse alternatives? When it comes to bioplastics, we know that this stuff still contains lots of harmful additives, and we could potentially be. Here we go. Let's see, it's a little bit of a lag.
Oh, weird.
We could potentially be replacing business as usual with a regrettable alternative, where we're replacing fossil fuels with bio-based feedstocks and continuing to impact toxic chemicals in the environment, greenhouse gas emissions, biodiversity loss, and soil depletion. So we really need to be thinking holistically about how we address this issue. On the plus side, we have a really rich trash and microplastics research ecosystem in California, in large part due to this committee that has supported a lot of these water and trash data challenges. And what I've found as being a researcher in this field for almost a decade is that the community is extremely open and collaborative and willing to share lots of things with each other. And so this is just a really tiny look at all of the cool things that people have created in our field as ways of sharing and addressing the issue. And we know that this openness attracts a diverse set of researchers. And really the best way to get these researchers is by removing barriers. So we need diverse researchers. We also need diverse stakeholders in the decision making. Just a little plug for a project that I've been working on with some people in the room. This is plastiverse.org, which is specifically aimed at removing barriers in plastic research. And we've got Dr. Wynn Cowger and Dr. Leah Thornton-Hampton here in the room today that helped me create this vision. I'm not trying to sell anything. We don't make any money from this at all. It's just a way of something that we can do for the community and make sure that we can all work together. And I guess we're probably over time, but there's lots of different ways that people can get engaged. I believe that these slides will be online, so people might be able to click these links. But really want to highlight the Microplastics Subcommittee, which is a subcommittee of the California Water Quality Monitoring Council Trash Monitoring Workgroup. We've also got the OPC NOAA Marine Debris Program, Ocean Litter Strategy, as well as the OPC Listserv. And again, ending with a little bit of hope. We don't need to be just lost in this sea of plastics and data and information. We can really work together to be prepared for the next wave and navigate through the existing challenges. Thanks, everyone.
Clearly with a high level update, we could talk about this all day.
Any questions, Steve?
First off, a compliment, fantastic overview that really set the stage nicely. Actually, a compliment to you, Nick, this wonderful agenda, because that will get more details and all. But the one thing you didn't have in this, and you're the kickoff speaker, so maybe this goes off to Nick, but what's the ask out of this? You all are basically leads for two agencies. What are you hoping to get out of the council? What can we do to help you? What should we focus our discussion around today?
Yeah, so you're going to hear from a lot of different speakers today that are really in the weeds of doing this research and finding ways not only to address the problem, but also what are the tools that are currently available? What are the resources available? And that's where we could be thinking collectively about what's the vision for how to use these tools in existing networks that we have and programs, but also in things that don't exist yet, or how are we going to basically, what are we going to be doing 5 and 10 years from now to address this issue?
So you'd like to see the council kind of develop that list of priorities?
That would be fantastic. Yeah.
That'd be an excellent deliverable.
I mean, so you had some of them in here. I just give you a start off with. I don't know. Where do you want to cover that in the agenda, Nick?
Well, I think where the opportunities come, and we do have the trash monitoring workgroup and the microplastics subcommittee that works on a lot of the stuff that we're going to hear about in the presentations today. I think where the council can really help is help support the recommendations that come out of the work groups and the subcommittees as it relates to, because it's such a booming enterprise right now, standardization and getting ahead of the game with method development and how the data is being managed and collected and reported is where the council can really provide input and support, and then kind of disperse that information across the sectors you all represent, because you guys are all on some level are going to be required to start collecting this data at some point. And it can be a challenge, and when we'll talk about this, I think a little bit about the challenges it is right now where everybody's kind of doing their own thing, and it's just kind of everywhere. And how what a challenge that is to try to make an effective decision or to get to where we're even now, to come up with some of these thresholds and why they are so highly variable, and they're not, the confidence is not the greatest. So like we get ahead of that now, and as people are throwing billions of dollars at this, the council can really help make sure that money is being spent wisely, and that we're spending our resources as wisely as we can.
So as we go through the individual presentations, we'll have weedier level
Yep.
suggestions. Because I think I'm familiar with most of the stuff and they're all doing great. And yes, we'll find little things. But I guess I want to highlight maybe 3 things I heard in your presentation, I think are just really big items. And I think you did, Scott, when you showed the variability in the thresholds. And we can do all the monitoring we want, but if we don't have interpretation thresholds, or if we're arguing about interpretation thresholds, then it's ineffective. You can do all the monitoring you want, but if you can't interpret it, why do you do it? So that seems like a very clear thing that cuts across many agencies. The second thing is that we are blind right now to nanoparticles. And as you say, we're pretty good now at the food dilution threshold, getting better with more studies. On the translocation, which is the biggest threat to humans, we're nowhere still in even how we monitor for that stuff, much less how we interpret it. So we got to start monitoring that. We don't have essentially any templates. The third thing that I hit is the tier 1, tier 2, and tier 3. Our methods right now are very expensive and complex. If we don't find a way to get a larger set of the community involved. So I think those are 3 things: evaluating the thresholds, nanoparticles, and how we build out the cheaper tiers for monitoring. The 3 things I'd like to see the council focus on.
I'll just add the importance also just of occurrence data and understanding what are the sources of those, of the physical occurrence data. Like what are main sources of plastic pollution? Knowing we have Senate Bill 54 coming online, the regulations are just in the beginning stages of being developed, but essentially how effective are those measures? Are there specific products, are there specific manufacturers that are essentially, we're identifying more through this monitoring as well? Could be very powerful as we're looking at, again, not just intervening before it reaches the water, but also that upstream source prevention as well. So I just want to.
Maybe Nick, that's the kind of discussion we can have as a group. Now we have 4 things, which are the biggest priorities.
So I just had a quick question on one of the slides. You had the washing machine. It looked like the wastewater treatment plant removed 95% of it. Does
into the biosolids.
Into the biosolids. So I'm just trying to figure out, because I know there's been recent legislation on washing machines that didn't go through, and so maybe that was the reason why. The other thing, just from a public perspective, since people can't see microplastics, that graph you had that said tons per kilometer squared, that was an eye opener for me, because it's, I think most people look out, especially in the ocean, they don't see anything. So just monitoring to let people know how much is out there be very important.
Thanks. Just for sake of time, I'm gonna move on. Richard, I see your hands up. If you could put your question in the chat, I'll work with getting that information to Scott and Caitlin, and they'll answer it there. But good thing Scott's already up here because he's next.
So I promised that I'd talk about what we're doing with drinking water, give you a little bit more in-depth update about that. So this is really just to provide an overview for the 4-year monitoring and reporting plan. So mentioned before, Senate Bill 1422, have to monitor for microplastics in drinking water. And as part of this effort, we also needed to define microplastics. This was an interesting ask, as we don't typically have to define other contaminants that we work on. But in the case of microplastics, we need to make sure that we're all talking about the same thing. And don't want to belabor the point, but this definition is something you probably heard before, but this is really groundbreaking, because this is the first time that a government agency has actually formally adopted any working definition, at least for the purposes of monitoring. And what's really cool about this definition is that other players around the world are currently picking it up. So we are actually setting a precedent, and we are harmonizing across agencies around the world. And this was, you can see here sort of like a timeline of how the different definitions have shifted and have eventually converged to what the State Water Board is using. European Chemical Agency just adopted a definition for intentionally added microplastics that is very similar to the State Water Board. It's super exciting. As far as monitoring goes, I gave you a little bit of insight into what we're doing with those monitoring methods. I just want to provide a little bit more of an update. Mentioned earlier, this interlaboratory validation study, just as a reminder. As part of this study, we sent out samples that we knew what was in them, the blind samples. And we got the data back from the laboratories about how much they were recovered. And this is just an overview of all the laboratories' recovery data. Looking at the log scale, this is about a 30% median recovery with a very high variability. And so first glance at this method is, well, gee, it's not very accurate. It's really undercounting and there's huge variability. But that's where I mentioned earlier, the size really becomes super important. And right now, we feel comfortable down to about 20 or 50 microns or so, depending on the instrument that's used, where we see a much tighter grouping of data, as well as closer to 100% recovery across the laboratories. Of course, there's some biases with respect to colors and shapes, but at least we understand what these biases are. So I mentioned earlier, we have this tiered monitoring framework that really came about by this assessment of the expense and the time that it takes to run these methods. And you can see here huge variability, but also we're seeing pretty high values for a lot of these instruments in terms of cost and the amount of time that it takes to run a sample. So for ramen, for instance, on average, it's 15 hours per sample and about $2,500. So that's very high for a single sample, for a single contaminant or a contaminant suite. And that's something that I think we should really be focusing on, like Steve mentioned earlier, getting the cost down, finding these shortcut methods. We are moving forward with this method though, down to 20 and 50 microns for drinking water. And we provide laboratory accreditation through the Environmental Laboratory Accreditation Program, or ELAP. ELAP accredits laboratories in any place in the world, and it can be any sector too. It doesn't need to be for-profit, or it can also be nonprofit institutes such as the Moore Institute for Plastic Pollution Research down in Long Beach. They're really close to accreditation. It's looking like they'll be done in time for the first monitoring samples. We're also working with our federal partners at the National Institute of Standards and Technology to get to a stage where we can feel very confident assessing these laboratories and being able to compare their performance in a standardized way. So we're working with them to develop proficiency testing samples and standardized materials. This is really exciting. Mentioned earlier, we did the health effects research. I really only talked about the ecotoxicity. So just super briefly about the human health impacts. Again, same health effects workshop that did this work. And we had far fewer studies to work with than ecotoxicity, 29 studies that we whittled down to just 12 studies that we deemed fit for purpose, and then went to expert review. So this approach that we developed for screening these studies, and then also what to do with the data, is totally novel. So this risk assessment framework is now being iterated upon by the scientific community and getting us closer to where we need to be, but we're still not there yet. And with this initial approach, we found that the majority of reliable information in the literature is about male reproductive impacts. So we know a lot about male reproductive impacts of polystyrene spheres, certain sizes, to rodents. Relating that to human health with our various exposures to lots of different particles is just not very reliable at this point. Again, we're working with this global community to get more data, and we added 22 studies to our database in COMEX2, nearly doubling the amount of data points that are available to us. So again, we're pouring over this, working with a WEHOP to really look over this data. And the sum of this was that we're not even going to derive numbers for regulatory use because the effects database is largely inadequate. We don't have certainty around the effect mechanisms, how these are actually causing harm, reproductive issues in these rodents, and we don't have good exposure data. Almost no data about what's in their food, and no harmonized drinking water data, which is something that we're doing right now actively with the State Water Board. So all that information were relevant considerations in the final ask, which is a plan for 4 years of testing and analysis. So last year we adopted a statewide monitoring plan. This includes the requirements and recommendations and really the steps forward for getting this work done. And the major challenge that we had with developing this plan is that we have these analytical methods that have certain strengths and limitations. They're really expensive. They can only get to certain sizes of particles. There's very few laboratories available that can run them. And there are different sources of contamination in the state that we have really just guesses at how much they're contributing to the microplastics loads for drinking water source waters. But even the particles that are getting to drinking water utilities might also be removed at certain rates. So balancing all of those considerations was a bit challenging. I showed this figure earlier about how microplastics can make it into surface waters and then be taken up into a drinking water treatment plant. Some of those may be removed. When it comes to groundwater, we don't really expect there to be much of a microplastic issue at all, as the ground seems to be a pretty good barrier for collecting the plastics before they get into a treatment plant. When it comes to surface water, most surface water drinking water plants are already removing the microplastics that we can detect with Raman or FTIR. And so they're getting down to about 1 micron with flocculation and sedimentation, meaning if we were to use these methods in treated drinking water, we probably wouldn't find much at all. But that's not to say that the particles are not there. We know that there's a lot more microplastics when you get down to the smaller size range, and they're only going to be removed by more sophisticated methods that are not nearly as common in California, like micro, ultra, nanofiltration, reverse osmosis. Those are typically reserved for removing certain contaminants that are dissolved, like disinfection byproducts, PFAS, that sort of thing. So all is not lost. We know the size distribution or approximate size distributions of plastics. So you get smaller, you get exponentially more. And so if we know this portion of the distribution, we can estimate the portion that we can't actually quantitatively see. And that's similar to how, if you know the shape of an iceberg, you measure the part that's above water, you can guess at what's underneath the surface, right? So we can use these methods in untreated drinking water, what goes into the plant. And we're planning to do that for our first phase of monitoring starting in next year. But before we get there, we still have to wrap up a couple of scientific objectives and build our monitoring infrastructure. So to do that, we're doing a sampling method comparison project with SQUIRP. We're doing some range finding of how these methods are performing in California's drinking waters and training operators and getting laboratories accredited. In phase 1, we're only going to have a couple water systems participate, about 30, and they're going to be looking only in source waters and ideally to getting us information about this tiered monitoring framework, how we can use surrogates, the lower tiers. And then in phase 2, this is where we hope to get data that's more relevant for human exposure, looking at treated drinking water, ideally with methods that are more sophisticated than what we currently have standardized, and looking at additional systems. So this is a interactive map right here. There's a bit.ly link for the water systems that are on our phase 1 plan. So you can see here we have a pretty good geographic spread. We also have a couple of disadvantaged systems included that will probably receive some financial help with this work. Good mix of wholesalers and community larges as well. And right now I mentioned that we're doing this pilot monitoring phase, wrapping up some technical bits. And one of the major components that's going on with this is a sampling method evaluation and optimization for something that looks like this. This is an inline filtration apparatus so that you can collect samples with 0 chance of airborne contamination. This work is being coordinated by SQUIRP as well as the University of Toronto and with a partnership of the Metropolitan District of Southern California. Once we get the monitoring data from this 4-year campaign, like during the campaign, the monitoring data will be housed in several different locations, but that are managed by the state. One of these places is California's open data portal. where we are requiring laboratories to use what's called the One for All data checker data portal that was developed by the Moore Institute for Plastic Pollution Research and SFEI. And this data portal is really essential to making sure that we have interoperable, high quality, comparable data, because we're working with extremely large, complicated data sets that have never been assessed by state agencies or federal agencies before. So don't expect you all to memorize this, but basically this is how the workflow is gonna work, where we're gonna have a standalone portal that's operated by CCAN or MongoDB, and that'll be linked both to CITWIS as well as CDIM, and maybe in the future even to Tomex and other things like OpenSpeci. So I mentioned earlier that we have the Microplastics Monitoring Subcommittee of the Trash Monitoring Workgroup, and we've been meeting quarterly for over 2 years now. We have 3 different work groups, one that's focused on sampling and analysis, developing a playbook. We've also got the Communication Toolbox work group to assist water systems in getting the message to consumers in a clear and reliable way, and also a work group focused on laboratory accreditation and data analysis. Our next meeting is in January. And as far as building the playbook, we are working from existing precedent. The California Trash Monitoring Methods Assessment Playbook was developed previously to this, and so we're using that as sort of a guide, starting point. And we've got Shelley Walder in the room here, who's leading that work group as well. As far as communication strategies go, we've already completed our work products for this. We built out a toolkit for drinking water utilities that provides recommendations for how to tell people how much microplastics you have in your source water in a way that doesn't just scare them and actually gives them the information they need and can increase and maintain the trust in the utility. And so one of the major aspects of this recommendation and toolkit came from a survey that was done by Arcadis this year, where they found that if you provide the message to consumers that the water utility is doing something actively about the issue, we're actively assessing the impact of microplastics in tap water and monitoring, that you maintain the highest confidence from the consumers in the utility. Whereas if you just tell them, well, hey, we found microplastics in your source water, we have no idea what they do to you, that doesn't really instill confidence in people. And so we want to make sure that we're getting them the right information, accurate information, but also not ruining their trust in the same process. I'm sorry? Okay, last slide. So this is just the overview of where we're going and all the dates that I mentioned earlier. And that is it.
Yeah. Quick question for Scott, or going to Diana. We're taking away from our lunch hour. We have it here, luckily. Any questions for Scott on what's going on with drinking water?
I'm really interested in these proficiency positive controls that you talked about, like where those are at, because I know those have been really hard to develop, and I don't know if you have any updates.
Yeah, currently it's in NIST's hands. We basically gave them the recommendations for what we'd like, and they were figuring out how to do it internally. I don't have like a timeline about when they're going to be developed, but that's an ongoing collaboration with industry as well. Actually, American Industry Council has been partnering with NIST on that.
I have a quick question for you, Scott. I was curious how this monitoring plan is being funded, how the work's being funded.
Sure. So we'll be issuing the monitoring orders to the utilities to conduct the monitoring. So it'll be up to each individual system to find the resources to pay for the sampling and analysis. Of course, if they're disadvantaged systems, then they can request funding for the SAFER program. All of the pilot monitoring phase is being funded by a small grant that we got from the legislature for this. We've also leveraged outside funding, such as for the Moore Institute's development of the data portal. But yeah, the monitoring itself is going to be paid for by the utilities.
Okay, last question, Fred, online.
Yes. Hi. Thank you. That was a great presentation, by the way. And I live in the city of Lodi, where our drinking water is from the Sierra snowpack, and we're surface water, and there's microplastics in that Sierra snowpack. I talked to our water treatment superintendent, and he gave me some good words of confidence that there's a lot of good filtration. But the data point that's really needed in this is the MCL, maximum contaminant load. How far do you think the state is away from?
We're right back here at we're right behind the music concourse.
Sorry, there's a little bit of cross chatter, just trying to mute everyone. Sorry, could you finish up your question, Brad?
Okay, yes. The MCL for microplastics, you see a lot of articles now that it's in the human body, like how you're kind of explaining. In this drinking water, how far do you think the state is from developing some type of MCL?
Yeah, great question, Fred. So I can't give even a good estimate of a timeline for that right now, because we're waiting on some key scientific studies that really get at the pharmacokinetics, particokinetics, how these particles are being actually working within a human system. That's really like one of the major components that's missing, and the exposure data. So I mean, anywhere between as early as 2 years, super ambitious, to maybe even 10 years from now. It's really highly uncertain, but we are working proactively, looking at the data, like I mentioned earlier, and working with OEHA to evaluate that data in a systematic way.
Thanks, Scott. Diana, sorry, we'll just have a shorter lunch, so sorry about the timing. But thanks, Scott.
And I know you all have been sitting for a while, so if you guys need to get up and stretch, feel free to do that. So while Nick is getting that started, I was asked to give a presentation about what we've been doing in the San Francisco Bay. And Caitlin and Scott have already presented a lot and referenced our San Francisco Bay data and really illustrated how powerful it is to have monitoring data to inform management action. So I'll just be re-emphasizing a lot of those themes and providing some more context for the monitoring data that we have collected. So just a brief introduction to the San Francisco Bay, which makes it a really great case study. We're a really large urban estuary surrounded by over 7 million people with diverse industries, and all of our wastewater discharge, or most of it, discharges to the San Francisco Bay, including stormwater runoff. And that's all the rainfall that falls on this urban landscape that drains through storm drains to creeks, rivers, and goes to the bay, which puts a lot of pressure on water quality. Fortunately, we have the regional monitoring program for the San Francisco Bay to implement water quality monitoring to inform management decisions. This is a really unique collaboration between regulated stakeholders like wastewater agencies, municipalities, dredgers, government like our water board, and independent scientists myself to implement monitoring to inform management decisions. And microplastics is an important focus area. And so we have a work group focused on microplastics. And our priority management questions are, what are the levels of microplastics in the bay? And what are the risk of adverse impacts? And number two, what are the sources, pathways, processes, and relative loadings leading to levels of microplastics in the bay? And we continue to review and refine our management questions to make sure our monitoring are answering these management questions. So I don't think I need to give this introduction about microplastics because Scott and Caitlin already gave great, but microplastics are essentially the detritus of our modern day use of plastics in all aspects of our everyday life. They're super diverse, different size, different shapes, different polymers, and when we analyze them, both the morphology and the type of plastic can give us a clue as to the source and inform what kind of sources we need to mitigate. For example, if we're looking at a polystyrene foam, it might have come from food packaging. And as Scott mentioned, the process of analyzing microplastics can be very challenging and is often very expensive because of the time that it takes to analyze these. Microplastics are extracted, we count the particles, oftentimes manually, and then we need an additional stage of polymer identification to confirm their plastic as well as what type of polymer they are. So in my presentation, I'm going to give a brief summary of the monitoring that we have done in the San Francisco Bay. Then I'll move on to our recent synthesis that re-emphasizes a lot of the themes that Caitlin and Scott gave on how our monitoring data informs monitoring strategies for both the Bay as well as for the state. And I'll talk about our future priorities, at least for what we identify as priorities for monitoring for the San Francisco Bay. All right, so monitoring that we've done, a lot of that has been completed in 2019, and when we completed this, this was cited as one of the most comprehensive studies of microplastics. We measured microplastics in the Bay, collecting surface water measurements using Mantatrol that Scott had shared before, both in the Bay and in the adjacent ocean. We sampled sediment, crayfish, and bivalves. And all of this monitoring was possible because we got a generous grant from the Gordon and Betty Moore Foundation of approximately $1 million to implement this 3-year study. And this was done in collaboration with Five Gyres and Chelsea Ruckman's group at the University of Toronto. For surface water measurements, we use this Mantatrol that is kind of like this spray with the mouth open. You skim the water surface and you drag it alongside the boat and collect microplastics over kilometers. And all of this is collected in a plankton net. The net has a sieve size about 300 micrometers. And so it's great for collecting larger particles than that sieve size. But for fibers and smaller microplastics, it's not as good, which we'll find out is a data gap that we want to address in the future. These circles represent the concentrations of microplastics we measured from each of these trawls, both in the Bay and in the adjacent ocean. And these circles are bigger in the Bay, indicating that we're seeing higher levels, like Scott mentioned. And we're also seeing higher concentrations in the wet season, indicating that stormwater flows, which in California is happening in the winter, is an important pathway for microplastics to enter the Bay. Most of what we see in the surface water measurements are fibers, followed by fragments, and then a smaller fraction of foam, film, and spheres. And again, these morphology and the type of plastics gives us a clue as to the source. Next, we also sampled sediment and crayfish. And these are really important matrices to understand impacts because in the Bay, these are the base of the food web. There's lots of critters that eat the sediment and then crayfish, and all sorts of larger organisms eat the crayfish, and this is how we're all connected. And sediment is an important repository for microplastics. We tend to think of microplastics as floating, but they will eventually sink as biofilm and other particles weigh them down. So we sampled in the Bay as well as a reference site in the Tamales Bay, which is a protected area far away from direct urban influence. And we saw concentrations much lower in Tamales Bay in our reference site far away versus much higher concentrations in the lower South Bay. Oops, okay, just took it off. Don't press that button. In the lower South Bay, that is much more heavily influenced by the urban environment. And the concentrations we saw in the Bay were much higher than what has been reported in other locations. And the same trend, we saw the same trend for crayfish, where we sampled in Tamales Bay and in the Bay. And again, we saw higher concentrations in the Bay. Another interesting thing is the vast majority of what we see that's ingested are fibers. And as Scott mentioned, while we know that microplastics are ubiquitous and wildlife and humans are ingesting microplastics, we're still uncertain as to what that means in terms of the impacts and the risk. So how do microplastics get in the Bay? We also monitored wastewater and urban stormwater runoff. We sampled 8 wastewater facilities that represent over 70% of the wastewater discharge to the bay. And again, we're sampling treated wastewater because that's what's being discharged. And we sampled stormwater from 12 different watersheds. And most of this is happening during a storm event. All the rain that falls on that landscape drains through creeks. And so each of these polygons represent one watershed. And all of the rainfall on that landscape drains through the single point that we sampled at. And what we found was that concentrations in stormwater runoff was significantly higher than what's in treated wastewater effluent, which is unsurprising because stormwater runoff is largely untreated. And so when we take these concentrations and multiply it by the flows in urban stormwater runoff versus wastewater, we can estimate the total loads from both of these pathways. And these results indicate that urban stormwater runoff is a much larger pathway for microplastics to enter the bay compared to wastewater. And what we're seeing in urban stormwater runoff are mostly tire wear particles and fibers. So when we made these findings in 2019, these made front page news because it was a really paradigm shift for us in thinking about what are the major sources of microplastics. We also made one of the first estimates of loadings to the bay, and we estimated 7 trillion were washing to the bay every year. So as I mentioned before, when we're looking at microplastics, both the shape and the type of plastic can give us an indication of where they're coming from. We saw tire wear particles, we saw polyester and acrylic fibers, which could come from textiles. Polypropylene and polyethylene fragments could come from plastic litter. Polystyrene foam could come from food packaging, as well as spheres from various consumer products. Next, I'll go into recent synthesis. Let's see. So we did a literature review to kind of summarize what we understand of how microplastic sources might be making their way to urban stormwater runoff. So for this one, this is for single-use plastics. And how does that get from use to litter, breakdown, and into stormwater runoff? And we summarize this into a conceptual model. To help summarize this, this is available as a report on our website. And this was meant to inform the development of the statewide microplastic strategy and was largely funded by the OPC. Another major theme that Caitlin mentioned is that tire wear particles are a major source of microplastics. We did another study, a desktop exercise where we estimated the total emissions of tire wear particles based on vehicle miles traveled in the Bay Area that the ARB had collected. And so this report is summarized in Moran et al. And we estimated that 15 to 19 million kilograms are emitted from vehicles traveled in the Bay Area. That gets deposited on the landscape, both on pervious surface like grass and what we call impervious surface like the road. And a small fraction of that, mostly the stuff that falls on the impervious surface, makes its way to creeks and gets transported to the bay. So we also made an estimate of the amount of tire particles making its way to the bay. Another important theme, again, re-emphasizing what Scott mentioned, is that when we're thinking about microplastics, we have to think about both the particles as well as the chemical ingredients when we're considering the impacts. And this was very much so for tire wear particles, where other scientists, led by Tian et al., as well as many other researchers, but they identified tire ingredients and specifically 6-PPD as being particularly lethal to coho salmon at concentrations that have been measured in urban creeks. Another important theme that came from our synthesis of this information is that air transport is an important pathway, particularly for tire wear particles and fibers that are particularly small and can be transported long distances. And this is also a really important data gap because we have almost no data on air monitoring in California. And so SFEI is actually starting a study looking at dryers and evaluating whether this might be a potential major source of fibers in the environment. Again, we're seeing so much fibers in the environment. We're trying to better understand where is it coming from. And this is a project that we are launching and is funded by both the OPC and NOAA. We also did another study in collaboration with some researchers in Spain looking at sediment cores. And by looking at sediment cores, we can look at trends. And even though we only looked at 2 cores, it definitely indicates that we're seeing higher concentrations near the surface, showing this increasing trend of microplastics, which we expect because these are very persistent contaminants. And so over time, these are only going to continue to increase. And by identifying sources, this is really important for informing strategy. So for example, by identifying tire wear particles as an important source of microplastics, as well as measurements of tires and their chemical ingredients in the environment, DTSC has used this monitoring data to support regulations on tire ingredients. Also, as we kind of think about other ways to address this contaminant, technologies that reduce tire wear or technologies that capture emissions can be ways to reduce tire wear emissions. And also bioretention rain garden as kind of a very downstream approach to removing or capturing microplastics in urban stormwater runoff. Okay, I won't go into this because Scott already presented on this, where he's used our microplastic data to do risk characterization. And a major data gap in that risk characterization is looking at those smaller particles. Again, we use a manta trawl because that is the most widely approach for collecting surface water data, but we're not capturing the fibers very well, and we're not capturing the smaller particles really well, which is really important for that comparison to ecotoxicological thresholds. Okay, so future direction for the RMP. So as we've synthesized this information and try to prioritize what are our priorities for the RMP, we identified wanting to do more monitoring of water and sediment of microplastics with a focus on data gaps from our previous monitoring, particularly those smaller particles, fibers, and tire wear particles that aren't very effectively captured or identified with our previous methods. We also want to do more urban stormwater runoff monitoring because that's the major pathway that microplastics are entering the bay. And again, wanting to identify those previous data gaps and improve our sampling methods, which we'll actually hear, and we're collaborating with Leah at SPORF and Andy Riverside, who we'll hear more about later. Additional data gaps from our synthesis are air monitoring, microplastic additives, and identifying previously overlooked sources of microplastics like paints. So have some key take-home messages. There are lots of tools available to develop actionable data, and current methods can generate useful information despite limitations. And urgent action is needed to address persistent contaminants. As we're developing these monitoring design, it's really important to link the study design to management questions and monitoring objectives. And depending on what your questions are, standard analytical methods may need to be supplemented with add-on methods, such as if you're really interested in tire wear particles, right, that will also impact your evaluation. And design can really help identify important sources. In addition to monitoring, it's really important to focus on the interpretation and synthesis of that data. Placing monitoring data in the context of these conceptual models can help us identify effective opportunities for source control and pollution prevention. And then synthesis provides opportunities for scientific collaboration across the state. And then with that, I'm happy to take any questions.
Thanks, Diane. Any questions for Diana?
Well, I noticed you had 4 potential major sources of microplastics, and you didn't review one of them, that was agricultural sources. And I don't imagine San Francisco Bay is a really good, would be a good case study, but did you see any microplastic of any great magnitude from?
Yeah, that's more of a, so we didn't really look at agriculture. It's more, that's meant to be a schematic, and for other locations, agricultural runoff might be an important pathway to investigate, but that is a gap that we didn't should be monitoring it. Go ahead.
And I'll just add to that for the microplastic strategy development, that was one, I'd say, sector where there wasn't, there hasn't been as much robust data for, let's say, off-field sampling, and there's a lot of questions about method development. So our recommendation in the strategy was more a pilot agricultural monitoring and have runoff from soils, or is it being trapped in the soil, and that kind of thing. However, later in this agenda, there is a project in the Monterey Bay that does include then the agricultural watershed, unlike what we have here in Southern California, unlike San Francisco Bay. And so that was a huge impetus for OPC that to fund that project too. So we'll hear more about that later today. It's just beginning too, so that's my caveat.
It's Moss Bay also does a lot of agriculture, and with the numbers being so low in Moss Bay, there's a lot of smaller farms there that feed into that water too. The particles are much lower.
Thanks. How can you give us a broad range timeline on how close we are to getting robust, standardized, and cost-effective tissue monitoring in fish, particularly in shellfish?
Yeah, that's a great question. I don't do the tissue monitoring, so I don't know, Leah, if you have any thoughts on that.
Yeah, so you're asking for shellfish? Fish and shellfish. So for shellfish in particular, Karen's gonna talk about our Bight monitoring program. We're gonna be looking at microplastics in shellfish. So we will be getting some preliminary occurrence data on shellfish very soon. And then on the methodological side, Charles will talk about this for sample analysis. And I'll talk about it on a collection side that we're preparing standardized methods for collecting and analyzing microplastics in biota as well. Perfect. Thanks.
Brad, I see your hand up online.
Yes, I had a question. A great presentation, by the way. And I go fishing a lot in the San Francisco Bay Area, and I think of the Dungeness crab and the salmon, and I think of all of this work that you're doing with the tires. Where are the microplastics for the tires predominantly found? In the sediment, or suspended in the water, or floating on the surface? Did you mention that? Or I'm just kind of curious.
Yeah, that's a great question. Well, I have to first say that after we did the monitoring, we did identify that tire particles was not very well represented in our sampling. Tire particles do tend to be more dense, and so they are discharged to the bay. We're measuring in stormwater runoff, but we're not seeing in our surface water measurements, so they will probably end up in the sediment. And we didn't see, well, we only looked at crayfish, and we didn't see, we saw more fibers than tire particles in the crayfish. So that's specifically to the bay. If anyone has any other comments, if you, yeah.
Any other questions?
But it kind of speaks to some of the method and analytical challenges for microplastics. We do include tire particles in the definition of microplastics, but sometimes they require different methods.
Richard?
Hi there. Can you hear me?
Yes.
So I was directed to ask my questions in the chat, and I just wanted to point out that I have asked a few questions in the chat and not seen any answers. So I'll just keep my eyes on the chat.
Thanks, Richard. We'll get to it. Okay, with that, thanks, Diana. Appreciate it. We can break for lunch. Still gonna hold tight to the back at 125 timelines. The lunch is in the hallway here. There are gluten-free and vegan options, I believe. So help yourselves, and we'll be back here 125.
So, yeah, so we have me, the host, we have CSU water, and we have CSU egg as well. So, these USDA grants, it's called.
Hey, welcome back, everybody.
Yeah, very, I'm like,
Okay.
we should.
Yeah, we should be done.
The wrong way, I'm sorry. And I think I-
Welcome back, everybody. Hope everybody enjoyed their lunch. Move on with the where are we monitoring piece of the puzzle. So now I'll hand it over to Lynn Calgary.
Thanks. So I'm gonna be talking about a really brand new study that we're doing in the Monterey Bay. And we're focusing on the entire microplastic budget going into the bay, especially for microplastics in the surface waters. Our team, our PI, Matt Savoca, and also the National Marine Sanctuaries are several of our main collaborators in Stanford. So for those, I'm sure everybody knows where Monterey Bay is here, but it's a really unique bay. It has this really deep canyon right in the center and makes it a really interesting place to study microplastics. I'll talk about some of the background of different studies that have happened there in the past. So this is a conceptual diagram of the food web that's going on in Monterey Bay. And now we have integrated plastic into this food web as well. And some of the previous work that's been done was done from a graduate student. And they surveyed microplastics in the surface water at several different locations. My boyfriend is Lauren. And here's all of her samples. She did a very typical manta net tow behind a boat. Did filtration, density separation, digestion of the samples, and then found that there were a lot more plastics near the shore, especially at the boardwalk location near Santa Cruz, than at their offshore sites. Was kind of the major finding from that study. And when we compare these concentrations that they're finding in Monterey Bay to the SF-based study that SFEI did that was mentioned earlier, and Carolyn Box was one of the leads on that. We see that the Monterey Bay really has similar concentrations to other national marine sanctuaries, but also we see near shore, we see similar concentrations to the SF Bay. And this really suggests that there's near shore surfaces, and this is kind of the inspiration for our project, investigating where these sources are, how are microplastics getting into the bay. Another study that was done by Elena Choi looked at microplastics in the Monterey Bay, and they looked at microplastics within the water column by taking this sampler and sampling at different depths. They found that there was this mixed layer where you saw this really different concentrations start to occur, but in general, plastic concentrations are, from my perspective, pretty continuous throughout the water column. You see similar on the surface and down below, but we can use this model and these other observations to start to calibrate our own model and our own assessment of what's going on with the microplastics in the bay. And Matt Savoca worked on this project recently published to assess how much microplastics whales were eating in the Monterey Bay. So there's you can tell there's just a ton of different studies that we already have that we can build from. And this is our study. So what we're going to do is we're going to sample in the near coast, near major river mouths. We're going to sample at the beach, right at the river mouths, and then we're also going to sample in the rivers. And our major objectives with this are to quantify microplastic flux between the rivers, beach, ocean, and biota, use a weighted evidence approach to determine sources of microplastics in the Monterey Bay, develop citizen science to gather plastics data on Monterey Bay beaches. And the thing I'm really excited about right now is this mass balance framework to inform ecological risk assessments. I'll probably have a little bit of time. We could talk about that toward the end too. Maybe you'll have some ideas about how we could do that. So for the first objective, we're going to be quantifying microplastic flux between all of these different compartments into the bay. We're taking somewhere between 100 and 200 samples. We're gonna collect and extract that, and we're advancing these automated techniques using a mapping FTIR approach, which gets at some of the comments that Scott made earlier. We're really trying to move away from particle picking. We're going to still be doing some particle picking, but we're going to be developing this new automated approach where you can just take the sample, scan it, find the microplastics in it. And this weight of evidence approach to determine sources. So we have some hypothesized sources. This is kind of a unique one in the Monterey Bay. Agricultural plastic. I was out there in the region, and I was looking. I was like, "Are those solar panels out there?" Because there's like all these shiny, reflective things out in the landscape, but it's actually black plastic that they're using to coat the agricultural fields, and it's so extensive that some regions, it's just a whole hillside is coated in black plastic. So that was kind of a big eye opener and good thing that I was able to go up there and like really see that, to see why they think that this is one of the major sources of plastic pollution. Because a lot of times that plastic doesn't actually get, collected very thoroughly. It can get ground up, it can escape, and they've done some studies that have found they're able to see it in the river too. But also one of the major pathways getting the agricultural plastic to the bay is through the stormwater. So we're still in like pretty conceptual stage here of this project, but the strategies for assessing the sources and pathways, we're planning on doing a PCA between all these different metrics that we can measure about the microplastics. We're going to measure as much as possible, look at seasonal variations, sample spectral similarity. This is kind of a newer thing. So we're actually going to look at the spectral fingerprints and try to compare that across samples to see if we can see like, oh, did the particles in this sample most likely come from a river or most likely come from an agricultural field or something like that. So I'm pretty excited about that part. And then, let's see. And then we're also going to do a meta-analysis between all the other studies that have been done in the past and add our data onto it. So here's the mass balance framework. Why I'm so excited about the mass balance is that we're going to get this wrong for sure, and that's going to teach us something, and we're going to have a very quantitative way of learning things. So this is the mass balance straw man that I'm going to propose. It's that microplastics in the Monterey Bay surface water, the change in what we see out there can basically be predicted by the change in beach plastic, river plastic flux, ocean lateral flux, like going in and out of the bay, and then ocean vertical flux, like going up and down. And then change in microplastic in the ocean biota. So that's the straw man that we're working with right now. We may find that, for example, beach plastic, this equation doesn't add up. Beach plastic are off by 2 orders of magnitude, with what we're seeing. And those kind of insights are going to lead us to our next scientific question. Like, why can't we get that number right? Or maybe there's another compartment we haven't even thought of. The atmosphere isn't on here. I know Diana mentioned that, and maybe that's a huge deal, and we need to actually consider that. So this is kind of the approach that we're going to work with in the Monterey Bay to really try to holistically understand how microplastics are moving around and getting into the bay. So this is my last slide. This is our timeline. Like I said, we just got started. Actually, we're a little bit ahead of schedule because we're not even supposed to start until 2024. But yeah, we just went up there and did some sample piloting and doing some method development. We're going to be sampling throughout the whole 2 years of this study. Sample processing is going to be happening for the whole time too. We're going to write some publications. There's going to be community engagement through the beach sampling. So that's an exciting component too. And then we'll do some communication toward the end. So, yeah.
Thanks. Any questions for Wynn?
Oh yeah.
Wynn, thank you for this information. My question is, I guess, related to your monitoring method for the river plastic flux. How do you approach measuring flux in a river?
Yeah, so we're gonna have measurements of the discharge at the time of sampling, and then we'll also have measurements of the microplastic concentration that'll be depth integrated in the water column. But we have this really new device that Pan Chrome developed, which is really clever. It's basically, we have this box that we lower from a bridge, and it has a spigot that comes down like a hose intake. And you can lower it down just at the surface and just suck up the surface. But you're out of the water, so you don't have to worry about like trees and stuff like that hitting your device, which has been kind of the pain for a while. And then you lower it down a little bit, and then you can get lower down and
So you're taking measurements throughout the water column.
Yeah. Yeah, and they're going to be pretty big measurements, like on the order of at least 100 liters, 1,000 liters with a pump, which is going to take.
Will this be wet weather and dry weather?
Yeah, but mostly focusing on wet weather, because one of the interesting things that happens in Monterey Bay is that the river mouths close. And so there's actually no connectivity between the river and the ocean for much of the year. It's only when the mouth is open that you have that connectivity. So that'll be, we're going to focus on those periods of time to collect most of our samples.
Wow, thank you.
Yeah.
I also got a question here. I wasn't entirely clear what the delta is for the surface water. Is that a change over time or?
Oh, yeah. For the surface water, yeah, that's going to be the change over the course of our study. We'll have multiple, I think on this, we'll have multiple sample measurements that'll be taken throughout the whole study, so we can see, like, estimate how it's changed over the entire study.
There's a question online, I think you may have answered it with the box device, but it asks what sampling equipment are you using?
It depends on where we're at. So in the ocean, actually we're mainly using a pump system, definitely mostly inspired by the work that SFEI is doing, as well as some of the stuff that we're doing with OPC and Andy Gray. So we're going to be using a pump system, and that's because we want to collect smaller microplastics. And one of the issues with using nets is they only go down to about 300 microns in size for the most part. And so you're missing all those smaller microplastics, and we're really trying to push for the smaller microplastics in this study. On the beaches, we're going to use we're going to fill up buckets with sand and seawater and do a density separation right in the field, so that we can get the floating microplastics out of the sand and be able to measure them that way. We had this big debate at one point because we were like, we need like 100 pounds of sand per sample, you know, like how are we going to get this down to Long Beach? Yeah. So we found a solution for that, I think. There's another question, mainly. Oh, okay, you answered it. Oh, thanks.
Any other questions?
Yeah.
How far upstream are your river samples?
Above estuary influence is basically where, and that may move, especially with the closing of the mouth. So we may have to chase that location. But the big thing is, like, we don't want to sample the water in the estuary because it's really complicated for us to understand what that means in terms of flux going out to the ocean.
Right. I was just back to the agricultural question, thinking that those rivers have urban areas in the lower reaches, and the agriculture dominates just upstream of those areas.
Yeah, that's great feedback. Yeah, thank you.
Great, thanks, Mike.
All right, thank
you. All right, okay.
Thanks. So this is going to be a much more prospective talk. This is the Southern California Bight Regional Monitoring Program. I'm Karen McLaughlin, I'm the coordinator for the program. I'm presenting on behalf of Leah, who's running the trash and macroplastics element, and Charles, who's helping with the chemistry part of the program. The program is every 5 years, so we're looking forward to hearing this council's feedback on how to best proportion our future resources. We're going to tell you a little bit about what we're going to do for this program, but we're definitely looking for feedback, and it's great to hear from these other monitoring programs and what you're doing and where you're sampling, what's been most effective, so we can optimize for the Bight. So for those of you unfamiliar with the Bight, this is the Southern California Bight. It extends from point of conception to the US-Mexico border. It's about 24 million people living in the coastal counties of the Southern California Bight, so it's a highly urban environment. It's a great place to study impacts that humans are having on our coastal system. It's also a highly productive region, so we have this wonderful balance between how our economies are using our natural resources and maintaining those natural resources. So managers really need to understand what's happening and what human impacts are on the coastal zone to best manage this system. That is what the Bight program is designed to do. The Bight program is integrated, coordinated monitoring. No one agency leads the Bight program. SQUIRP facilitates it on behalf of all of our partners, but there are 84 different institutions that participate in the Bight program. We sample all the way from our deep ocean basins into our estuaries addressing multiple different management questions. And the idea here is to answer sort of the basic status and trends type questions that are not addressed by any single monitoring program. So a lot of different agencies will monitor around their outfalls or monitor their stormwater. The Bight program provides them the regional context they need to interpret those results. The program at a glance, again, I said about 84 different agencies are participating in this current cycle. They consist of SQUIRP's member agencies, but we also have a bunch of outside partners. So this is a great opportunity for us to interact with the people that we don't necessarily always interact with, from consulting companies to academics and state and federal agencies, as well as our NGO partners. Again, it's a regional condition assessment. The program is renewed every 5 years, so that allows us to keep on the edge of our current management needs, and microplastics is now a very strong driving force to understand what's happening regionally. So they're all, the management needs sort of drive these questions, and they're developed by consensus because we have all these people, we have limited resources, everybody has to agree on what we're going to be monitoring. The permit requirements, so a lot of NPDES permits sort of lay the foundation for what's available, but then we have a bunch of voluntary effort too, particularly from the NGOs and our academic partners who can leverage the vast resources of our field campaign to add on new compounds, which is one of the things that has happened with our trash and microplastics monitoring. The reason people want to add on is because of this consensus assessment. So it's much more powerful for the Bight program to say as a whole, academics or NGOs, the regulatory agencies and the regulated agencies all agree that this is a problem and this is the answer. So that's a hugely powerful statement that is then codified for managers to use. Because the program has a 5-year planning cycle, we can adapt to new needs and document successive management actions because we have this long-term trends assessment, which you saw when Caitlin showed that figure of the trash, the bag ban impact. It's also a wonderful opportunity to try new things outside of permit requirements. Like right now, nobody has a microplastics requirement for their monitoring. The Bight program is a wonderful opportunity to test that out and see whether or not it's a problem that we need to be thinking about in our sort of NPDES long-term. This is what's moving forward in Bight 23. We have our sort of standard assessments for sediment quality, water quality, focusing specifically on climate factors, harmful algal blooms, shoreline microbiology, is it safe to swim type questions, trash and macroplastics. We have a estuary assessment, as well as a submerged aquatic vegetation assessment. And then a leveraged element looking at shellfish, which will include the sort of contaminant suite that we look at for sediment quality, microplastics, and then harmful algal bloom toxins and pathogens. So the reason I wanted to go through all that with you is to sort of give you an idea of what the program does and what it's capable of, and that you can provide some feedback on how we might be able to incorporate microplastics moving forward. So now I want to show you a little bit about the data that we've had on trash. So we've been doing trash in the Bight program since 1994. And what we've been seeing mostly is through our seafloor trash, that's a trawl assessment of trash, and then our stream assessment, which is people walking in the streams. We see that trash is pervasive both offshore and in our coastal watersheds, and most of that is plastic. And then when we look at our trawl data going back to 1994, we see that both trash and plastics have been steadily increasing. So this is our macroplastics program, and we know that plastics don't go away, they just often break down and get smaller. So that sort of led to the impetus of looking at microplastics in our Bight program. And this, I'm not going to dwell on it because Caitlin already showed it, but it's a way to show that if we have these long-term data sets, including things like microplastics, that we can start to look at the effect that management actions are having on the occurrence of them in the environment. So in the 2023, our macro debris program will continue. We're going to keep doing those trawl assessments and we'll keep doing our stream surveys, but we are also adding an estuarine assessment. So we're adopting the stream protocols, which are the sort of trash playbook that the state's been using for estuarine environments. They're kind of walking in a grid now to look at trash along the rack lines in our estuary so that we can sort of connect our watershed trash monitoring with our oceanside trash monitoring. We're also incorporating our microplastics. So this is leveraging our efforts for the sediment quality assessment. So sediment quality is a probabilistic design that's randomly stratified across the different habitats in the Southern California Bight ecosystem, all the way from sort of the marine estuaries out to the deep ocean basins. Because microplastics are super intensive and very expensive to analyze, we've decided to focus on just the inner shelf strata, which is sort of this dark blue. There's 30 sites in that strata looking at microplastics in the top 5 centimeters of sediment. And then we'll have 30 sites spread out through our embayment strata, which include the sort of ports, bays, and marinas. And then 30 sites in the estuaries, which are sort of closest to our watershed outlets, as a way to try to divide on where microplastics are occurring in our Bight ecosystems as a first cut on what a monitoring program might look like for Southern California. This is where I would love to hear some of the council's feedback on whether or not this is a good design and how we might adjust it for the next Bight planning cycle in 2028. We're also including an assessment of incorporating how microplastics are incorporated into biological indicators. So Diana had a wonderful study looking at fish. We've decided to look at bivalves too, similar to what you guys have done, sort of leveraging past efforts we've done with the Mussel Watch program. So using those same sites because we already have some historical data there for some of the legacy contaminants that we're also looking at. But the idea here is to look at these 30 sites all the way up from just north of Santa Barbara, all the way down to Imperial Beach, looking at both the Pacific oysters as well as the mussels, so the Gala provincialis and the California mussel, to try to get an idea about how different shellfish might be accumulating microplastics. We didn't want to choose just one because we know that there's some differences in how they sort of absorb contaminants and release them, and the differences between the different types of chemicals. So in addition to microplastics, they'll also get the sort of suite of legacy contaminants like mercury and PCBs, as well as PFAS, which is a new chemical contaminant that we're interested in looking at for this Bight cycle. We're looking at the HABs toxins over seasonal cycles and the pathogens, sort of Vibrios and the norovirus that we see in some of these guys. So we'll have a wonderful data set to look at the relative importance of these different contaminants in this sort of economically and substance fishing type resource in the Southern California Bight. It's going to be multiple seasons, so we're going to look at samples during the dry season as sort of our baseline of what we think microplastics would look like in all these contaminants. But we're also looking at the sites for the other suite of contaminants, both during the wet season and the upwelling season. So there's an opportunity to add additional sampling for microplastics to this if it is deemed interesting or important by some of our partners. So yeah, that's the bivalves. And then in terms of our anticipated outcomes, again, this is very prospective where we've just completed the sediment quality sampling this summer. The shellfish sampling will begin in January. But the idea here is that we are using this current Bight cycle to test the collection methods and validate that these methods are applicable and usable and comparable across these different labs that are analyzing them and useful in an interpretive way for managers. So can we prove that the proof of concept that this sort of microplastics monitoring is useful for long-term monitoring? We'll have the continued monitoring data for the macro debris, obviously, which is super useful in seeing how trends are changing through time. We'll be able to map, in addition to the sort of bag ban, looking at the sort of straws, and as we start to move towards elimination of single-use plastics, are we seeing an impact on what we're seeing in our habitats? And then we'll have the first assessment of macro debris in estuaries, as well as the first large-scale occurrence data set for microplastics in sediment shellfish. So we're very excited about this study. We're very interested in hearing your feedback and thinking about how we might optimize for future bite cycles. If you have any questions, please feel free to email me or Leah about the program. And I'll take any questions.
Questions or feedback on the study design? Maybe.
And as always, there's opportunities to still get involved if you want to join any of these programs. Yeah.
Oh yeah, just the only flag, which we'll also hear in a moment, on the field sample collection method standardization, just the timing for that is phased depending on the environmental matrix. And I know the large gap in the Bight this year is the water column is a huge gap. Yes. So that's what I just want to flag, certainly for the next cycle, especially after the completion of this SOPs for water column, field data collection, just want to have that on the radar.
And I think there's a lot of opportunities to leverage what we do for the climate monitoring. So we have an ocean acidification monitoring program where we're collecting bongo net tows for pteropods and other sort of pelagic calcifers. And the net size is 200 microns, but there's opportunity, it's 2 nets, so we can always optimize for different microplastics if that's of interest too, or we can use those tows as well for assessment of anything larger than that mesh size. So yes, great. Yeah.
And then, sorry, I'm just going to add on back then to Wynn's presentation as far as, it's the near shore, or the hypothesis of having it bound, closer to shore, then that water column sampling too, then being brought, the harbors, bays, et cetera.
Yes, yeah, we do not do harbors for our water quality assessment, but there's definitely opportunities to collaborate on doing that. But the nearest shore sample for our or the ocean acidification side of things is, I think, 5 miles.
That's where I was thinking that's one leverage, but that seems pretty far offshore where we know the concentrations.
Yes.
Maybe a little less.
Yeah, and we have been collaborating with the Moore Institute on sort of San Pedro Bay type study with Andy. He's online too. So we have some preliminary data on how we might want to tackle that in the future, but that's definitely something that we should be thinking about if we want to add on something like that to the Bight program.
Yeah, just trying to get the gears.
Yeah, absolutely.
To hit on the water column stuff, while that's not specifically part of the Bight program, I think one thing that's worked effectively is that in part through the council committee, in part through other mechanisms, there's a community that is developed that's interacting a lot. And so while we're not doing it in the Bight program, Andy is going to talk later, has a program that looked at it outside of a couple of river systems. We've got a program at USC. They're starting to collect a bunch of samples and we're helping them, and they're starting to use the methodologies that are coming out of it. So it's not like we've got a very well-designed Bight-wide program for it. On the other hand, we're not naked.
I just had a question. We heard some from Fred, a tribal representative, that an interest in crustaceans like crab, or down the Bight, maybe this specific spiny lobster. Is there anybody talking about, or any of the partners thinking about the impacts of microplastics on those types of species that are consumed by people?
We haven't gone there yet. There's always a possibility of doing that. It's a collaborative program. So if there's enough effort or interest, then we have ways to bring that to the Bight program. We have worked with, or we do work with Fish and Wildlife, and it's a program that's sort of run out of SFEI, the Sport Fish Bio Monitoring Program. I think Stu is a part of that as well. So they're looking at contaminants in sport fish. It's probably very easy to incorporate a composite for microplastics. It's again just a matter of standardizing the methods and making sure that things are collected cleanly enough to be able to do that.
I was curious, we think that there's, crabs specifically in the north are tested to milk acid along with the halves and those things. I wonder if there's an opportunity there if they're collecting samples for that kind of analysis. It could also be leveraged for other types of analysis. But
yeah, and I think that's an unplugged resource. It's looking at some of these large regional programs that are already collecting samples that you could then repurpose for microplastics.
Very good one. Question, Fred, do you have a question?
Yes, I do. A great presentation, by the way. You're doing so much work, but there was one I wanted to ask that I don't think you mentioned, the fingerprint analysis of what the plastic was used for. Did you mention that in your work that you anticipate that? Because I think that could be really helpful. You didn't
I'm
mention
gonna
that.
look at Leah, because I'm not sure what the question is.
Yeah, so that type of analysis is very, very cutting edge at this point. So the methods that we're going to be applying for the analysis and processing on Bight are the ones that came out of the interlaboratory comparison study that Charles will talk about in 2 talks. So we have a really good handle on performance of those methods and what they can and can't do, but definitely looking to the future to be able to source track particles in that way. It's just very, very new, very still developing technology.
Thanks, Karen.
Yeah, so I'm Leah Thornhampton. I'm a senior scientist here at SCORP, actually in the toxicology department, though I'm going to be talking about collection methods today with my good colleague Andy Gray, who's joining us online. So I'm going to start off basically on where we're at in terms of standardization of collection methods through this initiative that is funded by the OPC. So Caitlin mentioned this morning that California has a statewide strategy for addressing microplastic pollution. It uses a 2-track approach. The first track is kind of no regret solutions. What can we do right now to kind of hinder or stop the flow of plastics getting into the coastal environment? But then the second track is what science do we need to advance these solutions moving forward? And this is a kind of 4-pillar approach. One of the major pillars to this is monitoring. This includes standardized methods, which I'm going to be talking about heavily today, for incorporation into a statewide monitoring network, which would hopefully leverage programs that already exist, like the Bight program. So method standardization, I'm sure I don't have to tell you, but I want to reiterate why it is so important, and especially in a field like microplastics and where it's at right now. We want to ensure that this data that we generate is of sufficient quality, that we can compare results across different methods if they're being applied for different questions, and that we have efficient data management. Microplastics, I think when you mentioned it earlier, or Scott, that these are really gnarly, big, complex data sets. So we want to make sure that the data that we're collecting is amenable to that. And if this goal is to come up with a statewide monitoring network for microplastics, we need standardized methods in order to build that network, because this will involve a huge amount of collaboration, organizations. We want to make sure that everyone is on the same page. The drinking water methods, because of SB 1422, have been adopted on the analysis side because of this legislative mandate. But when you get into more complex matrices, which Charles will talk about in the next presentation for analysis and processing, those have also been evaluated and they're being prepared for accreditation by ELAP potentially. But there's no legislative mandate to adopt these methods at the state level. So just want to point out that clarification. And at this point, there are some standardized methods for sample collection, processing, and analysis. So the drinking water method, as I already mentioned, and also ASTM has methods on analyzing water samples with low, medium, and high organic suspended solids as well. So especially when these legislative mandates were just passed, methods were kind of all over the place for microplastics. Everyone was finding microplastics everywhere, but everyone was using a different method. So things are kind of a mess. And even still, as I pointed out, most of these methods have not been standardized or adopted. We're getting there, we're making progress. But this has been a challenge on both the sample collection side and the analytical side of things. And this is important because we need to understand the accuracy of these methods. So how close to truth are we getting? The precision as well as the cost. And when I say cost, that not only means like the consumables, the supplies you need to buy, but also the time it takes to analyze these samples, because it is a lot. And also pointing out that different approaches, both on the collection and the analytical side, can lead to results that are quite different from one another. So a classic example of this, early on, Diana mentioned, the use of manta trawls, where you are using a towed net to skim the surface of the water. This is great because you can cover a large area, you can capture a lot of particles. However, the mesh size is usually somewhere around 300 microns. So those fibers are kind of slipping through that net like spaghetti noodles in a colander, and you're missing those small particles. So you might supplement that with a grab sample. And back when this kind of first started, these grab samples were typically around like 1 liter, because that's very practical to kind of carry around in your cooler. However, that low volume is not really representative of the environment that you're usually trying to sample when you're trying to say something about a site or the San Francisco Bay, for example. And then even when you try to bring these results together, it creates a lot of uncertainty by kind of integrating the data that come from these two different collection methods. So a lot of the work that SCORP and our partners have been doing is working on method standardization on the collection side of things, as well as processing and analysis. And what I'm going to talk to you all today about, and Andy is going to add to, is for sample collection. So, like I mentioned, this is a project that is funded by the OPC. This kicked off in early spring of this year for sample collection, where our goal was to develop and evaluate sample collection methods for microplastics. And we are specifically focused on 4 different matrices. So ambient water, typically thinking about sampling in like the ocean, stormwater flows, sediment, and biota. So focusing on these 4 different matrices. And the big outcomes from this project are standardized SOPs, application guidance. So when one method is appropriate, but maybe if you're in a different situation or if you have a different type of scientific or management question, you might go for another. Understanding the disadvantages and advantages of one method versus another, and then comparability across the two. Because right now, a lot of that is quite murky in the field. So our general approach is kind of these 3 steps. The first one was the workshop that we had this past spring to build scientific consensus, basically bring all of these experts from around the world in this very room and basically hash out, are there methods that are ready for evaluation? And if so, do we need to design a study to evaluate them, or can we just move forward with designing an SOP? If an evaluation study was needed, or if the expert groups determine that one's needed, then we actually need to conduct that study to better understand its performance, uncertainties, and limitations. And then the final step of this will be generating SOPs and formal guidance documents. So as I mentioned, the workshop has already happened, and we are currently in a mixture of steps 2 and 3 right now. So after this workshop, our dedicated workshop participants continued to meet virtually in groups based on the matrix that they had their expertise in. And right now, we actually have SOPs for sediment and biota, and they're currently being applied in the Bight Regional Monitoring Program. This was really exciting. The timing worked out really great with this project and the Regional Monitoring Program. And the reason we were able to move forward straight into SOP development for these matrices is that they largely adapt existing techniques. So for example, the sediment collection is still a Van Veen grab. There's just extra things you need to do on top of that, typically to prevent background contamination, since aerial deposition of microplastics is a big deal. But with that additional guidance, the experts felt like, we can write this SOP, we understand the performance limitations. Right now, we're working very hard on the ambient water side of things, but it's looking like this is going to be a combination of guidance for doing both pump sampling, so similar to like the technique that Scott was talking about with the inline filtration. You can sample large volumes of water, you don't have to worry as much about background contamination, as well as the net sampling side of things. So when you use that is comparison to pump and those sorts of things. And we have planned studies to evaluate stormwater methods. This was the area where experts felt that felt like we had lots and lots of questions. So this is going to be looking at a combination of flume and field applications, which when I turn it over to Andy, he is going to talk about. And so before I turn it over, I just want to point out, this is kind of where we are in terms of collection methods for microplastics. We have all of our different matrices here, and in terms of where we are on SOP development. So for drinking water, and what I didn't necessarily touch on in detail today, this is part of the pilot drinking water study. We're evaluating collection methods, as Scott mentioned earlier. ASTM actually already has a method for collecting wastewater. And these are the 4 matrices that we're working on in the current project. What you'll notice that is empty in the adoption column is that because there's no legislative mandate for these to be adopted, this is something that we could choose to do to ensure that everyone gets on the same page. So with that, I will turn it over to Andy.
Hey, Leah.
And if you just wanted to say next slide, and I will advance the slides.
Sure. Hey, can everyone hear me?
Yes.
Great. Yeah, thanks for putting up with me for this. I'm up in San Francisco for the American Geophysical Union's fall meeting, but it's a pleasure to be able to join you remotely today. So as Leah mentioned, my group is working with SQUIRP and a number of other experts on this stormwater study for monitoring microplastics. Really we're going through a common series of operations, beginning with a literature review and preliminary study design. Both of those have been preliminarily completed. And as Leah mentioned, we'll be conducting a flume study and field trials in support of the development of a standardized SOP for stormwater monitoring over the next couple of years. Next slide. So, the important thing to keep in mind with stormwater monitoring is that, we're really facing a lot of the same challenges that everyone's encountering when they're monitoring ambient water, with the exception to some degree with concentration, because we often see much higher concentrations in river flow than we see, say, in the ocean, but still a consideration. But we have a number of additional challenges as well, that most of which are related to river flow. And that includes maintaining flow velocity at the sampler intake, the fact that we can have non-uniform distributions of microplastics across the water column. We're also dealing with this very high energy and debris-rich environment with a lot of variability in concentration and character as well. Next slide, please. And so, not to get too into the weeds, but essentially it's very important to consider the velocity of flow that you're encountering when you're sampling in a river. And the only way to really ensure that you're not biasing the sample that you collect is if you don't disturb that flow velocity at your intake. That's called isokinetic sampling. That's been the goal of my group that we've been using so far, as guided by previous knowledge from suspended sediment sampling in rivers. And the USGS has done a lot of work. This figure comes from the USGS back in 1999, but work on these kinds of issues for sediment sampling began decades before that. But to date, people haven't done much to evaluate the performance of these different kinds of samplers for microplastics. Next slide, please. What we're seeing in rivers here in Southern California, it's often the case that we'll find anywhere from, single-digit numbers of particles per cubic meter, all the way up to tens of thousands of particles per cubic meter. So it's a dramatic range in concentration. And this is for coarse microplastics, generally microplastics over 250 microns. We see much higher concentrations, most likely for finer microplastics. And in those cases, that necessitates oftentimes the deployment of different approaches depending on what size range of microplastics you're targeting. Another issue is that these are just very high energy environments, and it can be tricky to get samplers into the flow field, and it can be also hazardous at times. So all of that has to be taken into consideration. Next slide, please. And so in general, people have approached monitoring of storm flow with things as simple as grab samplers, buckets, bottles, pumps, whether those are hardened in auto samplers that are part of like broader flood control infrastructure and monitoring programs, or portable samplers. And then other kinds of passive intake samplers, like nets, what you see on top, that's a bed load sampler that we've used for microplastics, retrofitted with a current meter, or isokinetic bottle samplers, like you see that kind of white looking fish looking bomb thing on the bottom. Next slide, please. And so not only do we have different kinds of samplers to think about, but also different kinds of monitoring approaches relative to the water column or the flow field that we're dealing with. And that can range from point-based sampling, where we're just withdrawing samples from a single point within that cross-section of the river, or distributed point-based sampling from, sampling from multiple points, or depth or flow integrated sampling, where we're actually integrating sample collection across the flow field. Next slide, please. And so as we progress through the beginning of this project, we've completed some preliminary literature review. And so what we've found so far in looking at reported studies from the US and Europe that have where folks have been monitoring stream flow for microplastics, most of them have been conducting their sampling at the surface or subsurface using point-based techniques. Most of them are using grab and or passive, net intake methods. And really most of that work's been conducted at low to moderate flow conditions with a real skew towards base flow rather than storm flow conditions. Next slide. And so as we move forward with the study, we'll be working with Vamsi Ganti. He's a professor at UC Santa Barbara. He has an experimental hydraulics lab with a flume, a 17-meter long flume. We've been in the process of recruiting a postdoc to help us with this work, and we're now finally in the process of hiring Hamid Reza Rahimi to work with us. And the idea here is that we're going to evaluate sampler efficiency and performance in a very controlled environment, right, where we can have an independent test on the concentration and kinds of particles that we're introducing to these samplers and on the hydraulic conditions that they're experiencing in order to evaluate their performance. And so the timeline for that is we should be getting started as we move into the spring and summer this year. Next slide. And so for field trials, we also want to evaluate different kinds of samplers and sampler applications out in real stream flow. And so we're going to be using depth integrated techniques along with fixed point auto sampler and surface dip methods. The study systems that we'll be working in are flashy urban rivers and channels here in Southern California. And we should begin that portion of the study both this wet season, and then that may potentially also spill into next wet season as well. Of course, in this case, we can never know exactly what is in the stream, but we'll be able to interpret the samples collected by these different devices also in light of the results from our flume experiments. Next slide, please. And I should point out that the field trials that we're doing, they're really leveraging the fact that my group's been funded by the LA County Safe Clean Water Program in those 4 watersheds, Bayona Creek, Los Angeles River, Coyote Creek, and Dominguez Channel, to conduct a microplastics monitoring study. We're leveraging that work and then adding on additional sampler types and approaches for this method study evaluation. Next slide, please. And so the goal then is to take this work and analyze the results of our flume and field trials and synthesize our results in order to inform the development of an SOP, hopefully for adoption by the state of California. Next slide.
Yeah, thanks, Andy. Yeah, I'll just point out that it's been really great to work with Andy. We're really lucky to have one of the big players in this field working on these stormwater methods, especially something that's predicted to be such a major pathway for microplastics entering the coastal environment. And yeah, if anyone has any questions for me or Andy, happy to answer them. Yes.
Thank you very much, Leah and Andy, for the presentation. I guess, Andy, my question would be for you. So for the work you're doing on behalf of LA County Safe Clean Water Program, I'm just curious what prompted them to initiate the study, what management questions are they really seeking to answer through this monitoring? About their BMPs that they're funding through that program?
Yeah, so as I'm sure you're aware, the LA County Safe Clean Water Program is primarily an instrument to fund build projects, but up to 5% of that funding can go towards scientific studies. And those scientific studies in general should be oriented towards water resources, water quality, and human health related to the waterways of LA County. And so with our study, we've proposed to really continue to conduct and expand the conduct of our fundamental monitoring of microplastics in storm flow in LA County. We've already been monitoring a couple of those systems for a couple of years. And that study allows us to expand our monitoring to a couple of more systems and extend our monitoring for more years so that we can really start to get a better handle on the kinds of microplastics that we're finding in these systems, how much of it, what the flux is, and then also start to work on source attribution and then also take that knowledge and expand it to developing relatively simple empirical models so that we can expand out across the region and start to predict microplastics abundance, character, and flux in systems that we're not monitoring yet, so that we can inform future expansion of monitoring and consideration eventually of regulation.
Yeah. Thank you.
Yeah.
I'm curious about who will adopt the SOPs when they're finalized, like which body, is it going to be OPC or water boards or?
Yeah, I think that's the conversation that this group can start to initiate. So that's hence why I brought it up, because they're basically at the point where they're ready to go. So if we want to ensure that everyone's on the same page, then this is kind of our opportunity.
One follow-up question, is there an accreditation procedure for field methods like there is for lab methods, like eLab? Do they do field stuff too, or is there any other accreditation body for that?
Yeah, eLab is just lab.
Right,
yeah. I'm not aware of an equivalent for collection methods.
Right.
And just as far as accreditation, OPC doesn't have that authority, so it wouldn't be OPC. It's actually, I know in the microplastic strategy included accreditation. I believe that's reference to laboratory accreditation. So
we have, I guess I would say, adopted SOPs as part of our surface water ambient monitoring program. And I could probably speak a little more to it as well. So that's a model that we could use at the water board, and the board doesn't actually adopt. I'm not sure how we sort of approved that.
Right, so the surface water ambient monitoring program has quality assurance program plans, and depending on the different program, SOPs that kind of outline our standardized methods. And as you might expect, we encourage everyone to use them and adopt them so that we have standardized methods. But we accept data from many, many different sources, and our requirement is that folks utilize our QAPs or SOPs, but they were clear on the extent to which they have those documents and the quality of that data. Does that make sense?
Right. Oh, cool.
There was one comment in the chat asking about the progress for the drinking water SOP for sample collection. Is that something you can answer?
Yeah, Charles or Scott actually might be more appropriate in that, but correct me if I'm wrong, I don't believe that collection is, or like the actual study has started just yet. Like it just started like a month ago.
That's correct. The pilot drinking water study started about a month and change ago, give or take. And part of this is to evaluate the collection protocol.
Yeah, but no water flowing through a sampler just yet.
Thank you, Andy, for taking time away from the conference. Appreciate it.
Yeah, thanks everyone. I'm going to run off to a session that I have to run. Cheers.
Thanks, Andy.
Bye.
All right, next, Charles.
Okay, I'm Charles Wong, I'm Department of Chemistry here at SPOR, and what I'd like to do is discuss where the state of the lab methods are with regards to microplastics. I actually want to talk about two things. That's the first thing I want to talk about. The second thing I want to talk about is a request from OPC to present some selected preliminary data from the wastewater microplastics study, which they are supporting, which is an example of the use of these types of methods. So as has been discussed before, where we currently stand, I mean, this is basically this entire presentation. These methods are all over the place. Leah said that, Scott has said that. Scott's noted earlier in his presentations that the amount of literature has exploded, but the quality of the science seems to have gone down. It's actually gotten to the point where only a couple of weeks ago, the editors-in-chief of a major leading international scientific peer-reviewed journal in the environmental sciences and engineering has basically said, we're not even going to consider microplastic studies unless you characterize your collections and your laboratory methods and show what the performance is. If you don't do that, they're not even going to bother it. We need standardized lab methods. These, not just the methods themselves, but also vetted so that we know what they can and can't do through both single laboratory and multi-laboratory validation. That's the pathway towards accreditation. And then actually developing an accreditation program to show basic competency of the lab doing this. As Scott has noted, we have this for drinking water and we are getting this for other matrices. There's no legislative mandate for that. So if this is monitoring that is desired, then getting these methods are necessary. So Leah just showed you the first half of this table. So I'm showing you the other half of this table, which is where we currently stand with various environmental matrices in terms of not just collection, but also in terms of analysis. In terms of having an SOP that's gone through single multi-lab validation for drinking water, wastewater, ambient water, storm, for all these matrices, there are SOPs available. Some are from ASTM, some are from the SWRP study that I'll talk about a little bit later. The only one matrix that has gone all the way through to being through accreditation and through adoption is the drinking water one, as Scott has pointed out. We are working on taking the SOPs from the environmental matrices from our interlaboratory calibration study and generating a training course to be able to familiarize ELAB as we did before with drinking water, to familiarize with them with this so they can develop a study, develop an accreditation program, excuse me. So, but first off, on a very high level, what's actually involved in the laboratory? The name of the game is to separate your synthetic polymer particles from everything else in your sample, all the other particles that can interfere with it. So if you have something like, drinking water or sediment or fish, that means getting rid of all the other particles. For matrices such as drinking water, all the organic particles, things like fish, it's basically oxidizing it and destroying it and physically removing it, dissolving the tissue. So very much like Breaking Bad. Something like sediment, you do a density separation and all the inorganic particles, the sand and everything, they drop to the bottom and you basically collect what's out there. So you're left with stuff that then you can basically fractionate into various size fractions. As we established earlier, different size fractions can have different biological and ecological effects, and it's important to be able to distinguish the larger particles from the smaller particles. Ultimately, then, the idea is to get all these particles in the place where you can figure out what the concentration is, how many are there, and also figure out what they are. Are they synthetic polymers or are they something else? That's the basic upshot behind lab analysis. Now, if you don't have standardized methods, there can be some pretty extreme variability. In this case, this is a published laboratory calibration where over 100 laboratories, which were free to use the methods of their choice, quantify how many plastic particles, roughly about 800, these dash bars are the uncertainty and the true value, there are in clean water. And what you see here is that there's a lot of laboratories that are way off. not just a factor of 1 or 2 off, by a factor of like an order of magnitude, and in some cases several orders of magnitude. There's a lot of variability associated with this if you don't have standardized methods. So I want to talk to you a little bit about what one interlaboratory calibration study has done with regards to environmental injuries. This is the one we have completed. So this involved quite a few laboratories from the leaders in the field to novice labs that have never done this before in a number of countries for drinking water, surface water, for aquatic biological tissue, in other words, fish, for porous media, in this case sediment. Here are some of the actual samples themselves with known amounts of synthetic polymer particles and other particles. They would take candidate SOPs based on methods that people have used in the literature to quantify their performance, both in terms of technical performance, accuracy, how close can you hit the middle, and also in terms of precision. You got three replicates, how close can you cluster your shots to each other, as well as logistical issues, which is how much does this cost and how long is it going to take? So, with regards to what the performance was, Scott had showed a little bit of this for the drinking water. This is the full data set for all 4 of the matrices that were studied. And what we know here is that there is variability. Each of these dots represents the mean of each lab and shows the distribution. But this variability is constrained and we know what it is. That's important. We know what the method can do. It's certainly a lot more constrained than if you were using all sorts of other methods. Also, the more complex the sample, the more you got to do to get rid of all the other particles. And the more you have to do, the more likely it is you're going to lose things. So the environmental matrices tended to have, again, lower recoveries, but we know what it is and the variability is constrained. We know what that is as well. We also know, as has been discussed earlier, that recovery for big particles is way better than recovery for small particles. So for things less than 20 microns, you can see that the recovery is very poor. You see quite a few less dots because a lot of laboratories said, I give up, couldn't do this, but we at least know what it is. We know that this is a problem. And I would include fibers as part of this. Fiber recovery is also equally poor, if not more poor. They certainly are small, at least in one dimension, and they basically slide through sieves and do whatever it is they feel like to. In terms of particle ID, what this plot shows you is how many correct identifications there were across the media for both FTIR and Robin against incorrect identifications at the top. And the basic idea is that everybody did well. You could use spectroscopy to identify what these particles are. And as it turns out, novice labs performed, well, maybe not as well as expert labs, but with a little bit of training and following the SOP, they improve. And this is good because monitoring, labs that are going to do monitoring, especially accredited labs, are probably not going to have a lot of experience doing this. But if you give them some guidance, a modest amount of guidance, they can do well. And finally, this takes a lot of time and effort. Versions of this have been shown in previous presentations, but for all these matrices, in order to isolate the particles and identify them and count them and so forth, it takes oodles and oodles and oodles and oodles of time, and time is money. And that's one of the things that fell out of this. So the good news here from this study is that we have vetted these methods through a number of different laboratories. We know what the performance is. We know what the variability is associated with them. We know how long this is going to take. And we're currently working on revising SOPs and creating that training course for eLab so that they can go and generate accreditation programs just as they do. Limitations, obviously smaller particles, that's going to be a problem. And we need more rapid and less labor-intensive methods because these methods just take a long time to do. And that has led to what the participants put together and agreed on, which was this tiered monitoring approach that Scott talked about earlier, analogous to PFAS monitoring, where we could have simpler screening methods that don't provide as much information, but are much quicker and much easier to do. And if you have a number below a threshold, that may be all that's necessary, followed by others that would take a little bit more effort, but not as much as the ones that we have going on right now. So it is important to note that these tier 1 and tier 2 methods, basically, they are experimental at this point. There's performance is not known. None of them have been vetted through in the means by which we had just talked about for the tier 3 methods for the calibration. So to reiterate, we have SOPs for these various matrices that have gone through interlaboratory vetting, and some of them are in the process of being prepared for accreditation. Nothing has yet been adopted. So the second part of what I want to talk about today is, what about wastewater? One question is, that has been asked a few times is, how come the SQUIRT interlaboratory microplastics measurement study, how come wastewater wasn't one of the matrices? Was this an oversight or what was it? It was a deliberate decision. So that study was designed by an expert workshop in 2019. And after a fair amount of debate, it was decided not to have wastewater because it was going to be really, really tough to generate a realistic wastewater sample and have all the things in it and also have it clean of existing microplastics. That's a pretty big challenge. And if, for matrices, that was some work. We have also noted that wastewater is a pathway to the aquatic environment. So therefore, it's important to quantify what this pathway is to support the legislative requirements. And because there aren't standardized methods, the vetted methods, as we talked about previously, what we do is use the best available methods and, as necessary, improve on them to the degree that we can. So accordingly, what I'd like to talk about is, again, some preliminary. Oh, okay. Okay. Go back. Some preliminary data from the wastewater study for microplastics that is supported by the Ocean Protection Council with some additional support from CASA. So what is the study intended to do? It's intended to do two major things. The first thing is to figure out how much is being discharged from wastewater effluents for POTWs into California coastal waters, and what would these particles look like, and also get a sense for what kind of removal efficiency there is for different processes within these treatment plants. How much gets removed during primary treatment, during secondary treatment, during tertiary treatment. So with regards to how we went about doing this, how we went about collecting for these samples and processing these samples, it's not easy. Wastewater is, as we all appreciate, is full of crud. And collection was done using the only standardized collection method of wastewater that's available, which is the ASTM 24 online filtration. Basically what this is assemble a sieve stack going from biggest sizes to smallest sizes, pass known amounts of water over it over a 24-hour period. So you're capturing any changes that might happen over the course of a day. And then getting the materials captured off of the sieves and taking back to that laboratory for analysis. This can collect thousands of liters of waters, and that was what was done. The lab processing method was developed here at SQUIRT. And the reason we did that was, again, there's lots of interferences from thousands of liters of water. We've talked about, we've heard a number of presentations about the challenges involving, let's say, a grab sample, which has 1 liter of water. What happens when you put 1,000 liters of water into a container and then try to get rid of all that material? So this is data from a study which is currently in peer review. We've gotten the reviews back. They are favorable. where we're quantifying how much removal there is from some of these samples of all the organic and inorganic crud that we need to get rid of in order to isolate our synthetic polymers. And using the methods that we developed in-house, you can see that we get near quantitative removal of these interferences. And using other methods, it was much more challenging to get rid of this material. And visually, this is what it kind of looks like. Here's an example. This is what an initial filter, after you collected these samples and put them into a place where you can manipulate. This is what it looks like. So these are synthetic polymer particles and all the other particles that are collected. This is before. This is after. This is the exact same sample. By the way, the little blue dots are polyethylene spheres, which we added to monitor recovery from how much losses we have during the process. So they aren't particles that were actually in the treatment. So, so this study should hopefully be accepted by the journal fairly soon. So what data do I want to talk about here? I'm going to talk about particles that are bigger than 355 microns. So these are some of the larger particles. We have 7 treatment plants that are participating in this study. I'm showing data for these particles for 4 of these treatment plants. They're going to remain anonymous. There's 2 in the northern part of the state. There's 2 around here in the southern part of the state. There's 2 tertiary plants. There's 2 secondary plants. They vary in size, ranging from tens to hundreds of millions of gallons a day. These are primary, secondary, or tertiary treatments, depending on the specific treatment plant. The sampling was designed to answer specific questions. Some answered removal efficiencies, some answered what is in the effluent, some answered both. And so again, this is just basically a snapshot. Further details will become as soon as we're ready for this project. So what's the data look like? There we go. So what we have plotted here is concentrations in terms of particles per liter for primary, secondary, and tertiary effluent. So a couple of take-home messages from this slide. For primary effluent, we note that the treatment plants or effluent has somewhere in the neighborhood of single-digit particles per liter, 1 to 4 in this particular case. And we also note that there's a very significant, very large decrease between primary and secondary treatment, well less than 1 particle per liter, and an additional decrease from secondary to tertiary treatment, which is much, much lower. You can barely see some of the bars here. So how does this stack up with what people have done in the voluminous literature that Scott has mentioned for wastewaters around the world? As it turns out, it's pretty much in line. Now, we do have to be real careful of this, of doing these kind of comparisons. It's not apples to apples. It's apples to pretty much any type of vegetable matter available. Okay? Not even apples to oranges to fruit, just vegetable matter. Why? Because not only are the literature using whatever methods the study participants used, some of which are better or worse and have unknown performance. The treatment plants are very different. Some are primary, some secondary, some tertiary, some are different types of tertiary. Some are big plants, some are little plants. They serve different populations. They have different use patterns. They might have municipal use. They might have industrial use. There's a lot of variables here. So you got to be real careful not to read too far into these comparisons. But the basic upshot, as I said here, is that for primary and for secondary and for tertiary treatment, we know that the numbers we get, preliminary numbers that we're seeing from the study, are pretty much in line with what we observed. They're not that much different than the median value based on a global meta-synthesis review article that has recently been published. They're also not far in line with the previous SFEI study that was that Diana talked about earlier today. And in terms of removal efficiencies, what we note here is that from each of the major steps from primary to secondary, from secondary to tertiary, or for that matter, from primary to tertiary, these plants, we're seeing 90 to 99+% losses of synthetic polymer particles across these stages. How does this stack up? The literature basically says that treatment plants, especially treatment from start all the way to finish, if it's a tertiary plant, is incredibly effective. Gets rid of 90+% of what is basically coming in. And the treatment plants that we're looking at here in this study are entirely in line with it. So to summarize this discussion, again, the take-home messages is that the concentrations of microplastic particles from the preliminary POTW data is in line with it's exactly what we expect to see anywhere in the world. And that these types of decreases are also high, removal efficiencies appear to be high, and they're consistent with what we also see anywhere else in the world. I want to leave you with, again, our method status development. These methods exist. They're in the process of being completed, but the adoption is something that is, I think, something that this council may want to debate. That's what I have to say. Yes.
Thank you. Could you go back to your bar chart, please?
Too far.
That one.
Yes.
So can I ask, because you had 4 POTWs?
Yes.
Why
do we not see
it's
4
because
bars?
only,
Exactly. Some of the POTWs.
2 are primary.
2 were primary, there were 3 that had secondary, 2 were tertiary. They're not necessarily the same ones because different POTWs were asked to sample different parts in order to answer different questions. In an ideal world, we have POTWs sampling every part of their treatment plan, so we understand, we can do a mass balance. We've already talked about how expensive and time-consuming these processes are. So,
That leads me to do you only have 1 sample?
I'm sorry,
Is that, like, did you only take 1 sample from the price?
we did take 2 samples. I'm showing data from.
So, because I was kind of wondering about Wynn's study, like, are we at the place where it's just so expensive that you're not taking replicates necessarily?
Yeah.
Yes.
Oh, you are? Okay.
But to further answer your question, I mean, these analyses are thousands of dollars per sample.
Right.
They can take days and, depending on the method, weeks to do.
Okay.
So if you want to do 7 replicates per site, you're going to have to give up other things.
Okay. Thanks.
Karen.
This might be a question for the whole group, which is, to what degree is US EPA involved in we all talk about adopting methods. The state of California has a few methods we've adopted, but we're not an agency that, we have a lab accreditation program, but we're not, generally speaking, a method adoption agency. And so I'm just curious, is EPA at all talking about or interested in this effort?
I can answer part of that.
Yeah.
So they realized that US EPA methods take 10 years around, and they wanted microplastics methods sooner than that. So around 2017, 2018, they started with ASTM. So when ASTM has their microplastics methods, it says ASTM/US EPA. And they just had a meeting last week, and I'd be happy to share that with you. But the answer is that is kind of the part of what's going on with the US EPA. The other part is just other efforts elsewhere outside of ASTM.
So they're sort of hitching their wagon to ASTM's method standardization.
Yes.
But they're not going to promulgate the methods, or maybe they will in 10 years, but.
Right, it's kind of separate now.
Gotcha.
So let me elaborate on that.
Yeah.
EPA has also been involved with much of the studies of people. And the one that they really pushed forward is actually the sediment processing method for the collection. Because they don't do a lot of the other stuff, EPA, but they do have a sediment monitoring program. I have put forward a method for. So we're in continuous contact with them, and I think it's their intention So I said, they don't really have a big research program around this right now. I think it's their intention to on to what other groups. And they would love for California to adopt this. So they basically say.
We don't do that.
I
It's so
know.
weird.
So I'm not suggesting that we don't have time today, but I think that's a perfect role for the council to figure out. Whether the state board adopts it, whether the council endorses it, whether the regional boards, when they put in permits, essentially agree they're all gonna use one, however we get there. Because we've done the science to get us to the point where the scientists are agreeing upon methods and they've got it down to the right level. But we have to cross that threshold of, okay, who actually says you're supposed to use it?
What's Oregon doing, you know?
Waiting for us.
But it also brings up just another, we need the EP, I mean, if Terry Fleming was here, he'd be able to kind of respond to this more clearly. We've had trouble trying to get EPA to assign a liaison to the council. Maybe they need to like press on them as like an action item.
Maybe that's a good thing to do at the next meeting, maybe having a few speakers who could say, maybe from EPA, what's their process and how would they like to see California act in absence of them taking a lead on this? Having an ASTM speaker talk about what's their process and what they see as the relationship with California. Maybe put one of Karen's people on the spot, maybe put a regional board permit record on the spot and going, how are you selecting methods? Are you using this or not?
I think
That's a
Eric
perfect role.
Dubinsky is our guy, but
Huh?
Eric Dubinsky,
Right.
I think is gonna be, but we'll have to follow up. Yeah, no, I think that's really a good conversation for us to have. And because I'm seeing in every single presentation, nobody's adopted this, and then I keep thinking, is everyone looking at me because I don't know about this, you know? So, but I mean, I agree, it's something that we all need to, that somebody needs to put their stamp of approval on it.
It's gotta go to agriculture too, because someone's gonna tell you to do your fields when you put all the biosolids on there. Which methods are you gonna use? It's a perfect role for the council.
Yeah.
Yes. I apologize if somebody mentioned this already earlier in the day, but is sludge included anywhere like in matrices or SOPs that are being developed? Sludge, that's actually one of the ones which is kind of a tweener. So it's wastewater, but it's not, it's sediment, but it's not. Because the removal of synthetic polymer particles from wastewater treatment is to wind up with all the other solids that get removed, right, in sludge. And it is established that there's lots of microplastic particles in sludge, and it is a challenging matrix, very challenging. In the city of San Diego, all of our sludge gets turned into fertilizer essentially. We ship it to Arizona, so it's not our problem. But I mean, there's probably, a lot of interest to figure out, okay, you were looking primarily at effluent from wastewater. So how much, of the microplastics is coming out even in primary treatment and is ending up in the sludge and going somewhere else? We do have a couple of biosolid samples for this study. They're outside of this presentation, but that'll give at least a little bit of an idea of what is present in those biosolid samples. But ultimately, you got to get rid of everything else, and there's a lot of everything else to get rid of. Yes.
Charles, are there commercial laboratories that currently can perform any of these analyses?
Are there commercial laboratories? There have been a number. The answer is yes, but they haven't gone through accreditation.
Right. Okay.
So a longer answer is there are a number of laboratories that have approached us and said, expressed interest. We've even trained some of their analysts to do this and pointed them in the right direction in terms of the accreditation, and also noted with some of these working on this. Right. So there is interest in commercial laboratories doing this, and some laboratories are also finding new and better ways of tricking out instruments and finding effectively tier 1 and tier 2 methods. And we are also talking with them as well So if that is something that is desirable, there are people that are working on this that could be part of the answer.
That could be another thing that the council takes on, is that once the method has been essentially adopted in some capacity, what's the process by which laboratories are trained, encouraged, so you can build the capacity?
Yes.
Grants, he's not gonna sit there and try to start up a lab unless he doesn't have enough samples. But he's probably gonna need samples processed in some capacity in the future. How do we build the infrastructure?
Yeah, this is amazing work and thank you so much for sharing. Can you give us a range on timelines for the sediment and biological tissue SOPs?
Best guess, months.
Okay, great.
It won't be years or decades, because I believe some of this actually being edited as we speak by people in this building. But it also won't, it's not 9 o'clock tomorrow either.
That I wasn't expecting that. So thank you. Months is a
Sorry, Scott.
Questions? Great, thanks, Charles. Thank
years or decades. Yeah.
I'm gonna give a plug. Our lab is aiming to become the first commercial lab to be accredited. I think we'll be able to do it by February for drinking water. So we're starting to develop some of those. And if that's of interest to anybody else, we'd love to work with you all to figure out how can we get more people on board. I know we've been feeling so bad because Scott's like trying to get this study up and running, but there's no accredited labs and we're cranking full gear, but it's really hard. And I'm going to talk about some of the challenges that we're facing because it's really a data management problem to get accredited more than it is a methods problem. We have the methods, they're clear. The data is a cluster and we need to figure out how to manage it and manage it consistently so that we can reproduce our results and explain what happened to the sample. So that's what we're going to be talking about. And I'm research director of the Moore Institute.
I'm a second year PhD student at UC Riverside in Dr. Andy Gray's lab.
And I want to acknowledge that really this is a success story. These projects that I'm talking about, success story of the Water Quality Monitoring Council. I'm co-lead of the Trash Data Management Subcommittee right now with Tony Hale, and I'm also collaborating a lot with the Microplastics Subcommittee. So these have all been, we go and give presentations about these to the subcommittees. They've been giving us great feedback. Some of them are collaborators on our papers that we've written about this, all this kind of stuff. So this is really a time for us to be like, yeah, we're doing some great stuff here in the council. We're a nonprofit research group, and so we really take funding from lots of different sources: for-profit, government agencies, other nonprofits, family foundations, so many different things. I think there was at one point there was the NSF too. Hannah here is NSF Graduate Research Fellowship, so definitely want to give a shout out to them too, and the Ocean Protection Council as well. So I'll just step there. So we've already been over this. We're trying to develop these accredited methods for analyzing microplastics in drinking water because of Senate Bill 1422. And we also talked about the interlab comparison study that really spearheaded some of the methods that have been established. But like we said, it's really expensive. I mean, some of these samples, we quote people at $3,000 a sample to do because it's really a R&D effort to get the sample up and going. So there's a lot of challenges that remain in sample throughput, and that's kind of where we're at right now with one of the projects that I'm going to be talking about. And these are the data management problems that we're working with right now. So one of them is on the spectroscopy side of things. So after you've collected the sample, you want to analyze it, identify the material characteristics of the particles. Then we have data and we want to analyze that data and share it. That's a whole other challenge that we're working through. And then harmonizing, because people don't collect data in a standardized format. So you have to figure out how to get the data to talk to each other so that we can compare across labs. And really, this is our Lamborghini in our lab. If you want to come play with it, you know, come on over anytime. This is our FTIR IN10. We love it. It does hyperspectral scanning. You can do point and shoot measurements to try to. This will tell us what type of plastic we have in our samples. And this is the like classical figure of microplastic data. So you have a bunch of particles in a sample, and you want to know what are their material types, what are their shapes, sizes, colors, all these different characteristics. And you want to keep track of that on a particle by particle level so that you can actually make sense of all of the information. And you have all this extra information about like the spectral signature and photographs of these particles. So it's a really unique contaminant, not like dissolved contaminants where, you know, it's something that you can't really see. We can see these things and measure them in lots of different ways. And so here's a bunch of polyethylene particles that we have. We've been using these stainless steel filters to filter our drinking water samples. And we do a hyperspectral scan, and we have an algorithm right now that kind of tells us, it will make the particles stand out from the background. And I'll show you why that's really useful, because traditionally what people would do is one by one, you would collect a particle and you take it to your machine and you figure out what it is. And you have to manually move those particles to the machine. It can take 15 minutes minimum per particle, and you might have 100,000 particles in your sample. You have to do that. So that's where we were at, but I'll show you why we're trying to move more toward just scanning across the surface and doing basically the same thing as what the traditional, or we're getting a similar amount of data out. And so one of the challenges though with this hyperspectral scanning is you get this tremendous amount of data. You have hundreds of thousands of spectra per map that you have to analyze. And the traditional way of analyzing this type of data is one at a time, just like the particles, one at a time, and you look at it visually and you compare it to a known spectrum, and you kind of cross your eyes a little bit, and then you go, yeah, that looks right. If you're really good, you do the eye crossing. Yeah, I'm not that advanced yet, but I'm working on it. And so obviously this is very time intensive, and actually you can run correlations to try to figure this out, but those are very brute force, and it can take like 4 hours of computer time to run through these 100K spectra, even automating this process. So we've been working on some of those bottlenecks. So I'm showing you, like, this is actually one of the first times that we've shown this full process. I'm really excited about it because a lot of people have this instrument, this IN10. So this is going to be like a game changer for any lab that has these detectors. So what you do is you start out, you scan across the surface of your sample. We have this algorithm that basically tells us it'll make the particles shine brighter than the background. And with that, we can define a threshold of brightness of this is particle, this is not particle. So the dark areas are not particle, the bright areas are particles, right? And so now I've identified all of my particles here. And then once we've identified the particles, we can extract all the spectra. So let's say there's like 1,000 spectra per particle. We extract them, take their median. So now we're left with just one. We've compressed the problem from 100,000 spectra to like, 20. And now I run that through my, automated algorithm really fast and identify each of those particles. We can also do measurements just using standard image analysis techniques. We can measure the shapes and sizes of those particles. Still working on getting color added to this because we have to somehow overlay a visual image with the spectral image, get them to overlap and get that correspondence. So haven't quite unlocked that one yet, but something that we're working on next. And OpenSpeccy is really the workhorse of this procedure. We've implemented this in an open source software that's free for any other researchers to use. It's widely used around the world right now. I think it's really exciting. It's starting to become like the main standard for microplastics research. And it's because it really has features that are not available in commercial software today. So we can take these hyperspectral maps, do that compression algorithm that I described earlier, analyze all the particles automatically. So there's a lot that's going on in OpenSpeccy. And I want to shift gears a little bit and mention that microplastics are really diverse, and we all know this, just like their data. And so I talked about all these different types of data, right? You have your tabular data, your images, your spectra. This type of stuff is really challenging to relate. It doesn't fit well in like our spreadsheets, or it doesn't fit well in a SQL database. And so we developed this tool. Scott already talked about it. I'm going to go a little bit deeper, called One for All Data Portal, so that we could collect all of that data and make it usable. This is an AI generated image of my rendition of the One for All function, which is, beautiful free butterfly of data. You can see zeros and ones in there. Focus on, there's microplastics on the wings, and then 3 musketeers, because we're all in this together, all for one and one for all. So sometimes AI does some cool things. So the vision with this is that we're going to take data from accredited labs, send it to this One for All data portal. It's going to be sent to several other data portals, including data.ca.gov. And then we're working on some integrations to like OpenSpeccy, which I already mentioned, Tomex, which Squirp and Scott have developed. And so in this data portal, we want to keep it really simple. Just like we want the user to only do one thing. They just upload their data here. And then we want to walk them through everything else after that. So imagine you had your data, you just uploaded it here. And then you go, if there's any errors in your data, so we check the data to make sure that it's like conforming to our standards. If there's any errors, they get flagged, and then you fix them, and then you upload it again. And if you pass all the tests, then you're allowed to input a key, which we give you. So we quality control this stuff. Only certain people will be allowed to do these procedures. But if you have that, then your data will go up into the state data portal. And so I talked about one of the unique types of data, spectra, but also with these images, this is another very unique type of data that you might want to query. And we've been collaborating with Laura Markley to develop a portal for querying images. So you can, in this portal, you can click color, and you can filter all the green particle images. For example, you can filter all the green fiber images. And it's a really interactive way to investigate that type of data, because it's kind of a unique type of data. And this year, this is one of the most exciting studies for me this year. It was a database schema that was published by collaborators in Europe that they have really thoroughly vetted all the different pieces of information people capture on microplastics and conformed it to a SQL database structure, which is very complex and impressive. And we're currently trying to figure out how to get our database to conform to this standard, so that we not only have a standard here in California, but we have an international standard. That's kind of the idea. All right, and then I'm about to hand it off to Hannah, but I want to start by talking about one of the major problems in data integration. So you have, my data set, Hannah's data set, and we named things differently. This is a really common thing. One person says polyethylene, another person says PE, another person says high density polyethylene. There's all these different names, but we want them to all conform to the same value in our database. And so here you can get an example. There's like 100 different things people called polyethylene in the database that we're working on right now. And then I'll pass it over to Hannah.
Thank you. I'm going to talk a little bit about data harmonization and what I've been working on. So as Wynn and Scott and many people here have mentioned, there is a call amongst the research community for standardization of trash and microplastics data reporting. So we first wanted to assess what the current state of plastics data was. So we performed a meta-analysis on 68 different trash surveys in 69 different microplastic studies, and looked at any concentrations that they reported, as well as any semantic terms that they use. So any of those characteristics that Wynn mentioned, morphology, item, analyzed all the terms that these studies use, and found that on average trash surveys were only 20 to 30% comparable across studies, and microplastic studies were only 6 to 34%. So here we have some mean comparability metrics between studies here for material and morphology. So this is fairly low. So how do we go about addressing this? So we've come up with an algorithm here. Not the most updated slides, but we came up with an algorithm called the microplastics in trash cleaning and harmonization, or MATCH algorithm. That the first step here is through a relational table database, under what Wayne mentioned. So trying to make sense of all these terms and relate them synonymously via these alias sheets. So like Wayne said, polyethylene and PE, and then also hierarchically, taxonomically in these hierarchy sheets. So also, like you mentioned, polyethylene would be a parent term to like high density and low density polyethylene. I'm going to note that we did include trash and microplastics together in this database. We believe that trash and microplastics are inherently linked both physically through the degradation of mismanaged waste into secondary microplastics, as well as facing a lot of similar issues with respect to these categorical variables and how to manage them. So this database describes all plastic, regardless of size. So this database seems to work well so far. We developed this for NOAA marine debris. And because it does have this hierarchical structure, we're able to maintain the maximum specificity as possible, or we are able to lump into these less specific terms to make sort of more broad generalizations. However, we did face issues when trying to integrate terms that were outside of our database. So our database is fairly big. I think there's like 1,400 terms in it, but there are still words that people use to describe trash and microplastics not in this database. So we have looked to some AI-assisted semantic data ingestion techniques. So we use an embedding-based natural language processing model. So we take all the terms that are in our database and any terms outside of our database, pass it through this embedding model, and it turns it into these big vectors. So then we're able to compare all the vectors between terms using a similarity metric and essentially match any outside terms to terms that exist in our database. So far with the data sets that we have tested, we found pretty promising results. So outside terms to describe trash have matched correctly 78% of the time to our database, and microplastics about 74 to 81% of the time match correctly. So, and also note that this is just using OpenAI, so an open source software. This is not any pre-training or fine tuning at all. So this is, we believe, a fairly low to no cost option for groups moving forward if they do want to curate these sort of big data sets. So, and this also touches on a lot of what other speakers have talked about today. There are plenty of other data reporting issues that are non-semantic. So some other harmonization issues, we got all of the terms in our meta-analysis down. We condensed them to about a third of the number of terms that were used initially to make it more manageable. However, there were still other issues impeding accurate comparability across studies. So this includes, first of all, the size ranges studied. So I think Scott showed that big inverse exponential chart of size versus frequency. So you can imagine if different studies are studying different ranges of this distribution and reporting concentration, that you can't really accurately compare those much meaning. So that was one of the hurdles. And then also reporting particles, the metrics that you use to report particles. So you're reporting the number of particles, the mass, the volume, and also how correcting for these two could change the percentages of different characteristic variables in your meta-analysis overall. So first, this top figure looks at, we corrected all of our microplastic studies to account for the same size range. We chose 1 to 5,000 microns, and we found, first of all, that the concentrations increase up to 4 orders of magnitude in certain studies. And also you can see here that overall, the morphology types, some of them increase by like 1,200%, so very significant. And then we also looked on the bottom here, this is on the left is looking at a count of particles, and on the right is percentages by mass. So there are over 300% increases in certain morphology types. So recognizing the importance of data harmonization, also recognizing the importance of leveraging this existing data. We've also talked a lot about how labor intensive and expensive it is to do these studies. So if we can make sense of the data that we currently have, I think, yeah, it's worth investigating further. And recognizing how all of these different data cleaning techniques are interdependent, we combined all of these steps in more detail here in this flow chart into one data harmonization algorithm. So this is able to intake data for both trash and microplastics and data at both the particle and concentration level. So this is also, we have an existing R-Shiny app for that relational table database called the trash taxonomy, and this will very soon be live on that same website. Pass it back off.
I have another shameless plug for the Plastiverse. Tell everybody the Plastiverse is where it's at. You got stickers. You're looking for trash information, plastic pollution information, that's where to go. And I want to leave some other links up that I use a lot to share my code. It's all up on GitHub. We have data up on Center for Open Science. All our manuscripts are on ResearchGate. And then now I'm using LinkedIn because Twitter just became a little too crazy. So anyways, that's all for us. Yeah, thanks.
Okay, thank you. Any questions for Wynn or Hannah? So there was one question.
Are the Plastiverse stickers? Yeah, you got us. They are made of plastic.
And one above that was more related to, I think, the cost of your lab setup, like the FTIR cost.
Oh, okay, yeah. Yeah, the cost for the FTIR is somewhere between 200 and 300K. The cost for actually getting accreditation up and running is probably at least 2 or 3 times that. It's really expensive because it's just like you have to train somebody on all these new techniques. These aren't very common environmental forensics techniques even. So yeah.
Great presentations, you guys. You mentioned with the scan, are you able to do, how long does the scan take? And then also, are you able to do repeated scans? Because we know that, you know, one run might be, even we're talking about the same slide or filter could be 75% different answer second time. So are you able to do repeated, have you been able to calculate RSDs, that kind of thing?
Yeah, that's good. Yeah. So first part of the question was, how long does it take? It's about an hour for each scan. Second part, have we done repeated analysis? Yeah, we have. There is some variability when you repeat them, just like you found in your study too. And then was there another part of that?
No, I think that's
okay. Yeah, definitely some variability. I think it could be a part of the method that we end up fully going for. We're trying to push that method as the method that we use for accredited samples, to be honest, because that is going to save us a lot of time and money and actually make this type of analysis really scalable. So
that actually measures the particles as well, versus a lot of the other methods, they're just picking what's on the sieves and then counting for each sieve size rather than measuring.
Yeah. Thank you.
There's a question on there. How do you control the contamination in your lab using that method, your method?
Control for contamination. So right now we have several HEPA filters and a really aggressive cleaning schedule. So every day we clean, when we come in, we clean the entire lab. When we come in and clean the entire lab when we leave, we have positive pressure in our lab to keep particles from going into the lab. We also do not allow any synthetic clothing to be brought into the lab. We try to reduce the amount of plastic utensils that we're using in the lab, but there's some that we haven't been able to get around. That's most of the contamination controls that we think about right now. And then let's see, 500K setup, so similar to your estimate, but they already have an FTR. Cool.
Great work. Thanks.
Yeah, thanks.
Thank you. So we have a 10-minute break scheduled for now. Do people need a break? Want a break? It's been 2 hours since lunch. We can take a break, or we can ask Elizabeth to start presenting early to you guys.
go for it.
Okay. Elizabeth, you ready?
Sure. Of course. You're voting with your feet.
Putting with your butts.
Yeah.
Hi, everyone. Hi. Thanks for inviting me, and it's really nice to meet those of you I haven't met before. My name is Elizabeth Bight, and I'm the head of the engineering department here at SCORP, for those I haven't met before. And we have a little bit of a couple of objectives with this talk today, since this is the first time I'm meeting you, to well, actually, I should thank Grant, I think, for putting me up here today. Originally, we've developed a bunch of tools and calculators to automate and standardize data processing, some data processing steps for BMP monitoring within the context of a regional monitoring network that for best management practice, stormwater best management practices that we built for the Stormwater Monitoring Coalition. And then we got a grant to analyze microplastics. So we're kind of combining all three of those ideas as an introduction to you all on what we're doing here in this space in a single presentation. How does that sound? Woohoo! Thank you, Nick. So my first question is, are you all familiar with the SMC, the Southern California Stormwater Monitoring Coalition, what it is? Yes, I'm getting a lot of nods, so then I can just skip this slide. Great. Okay, so the Stormwater Monitoring Coalition has an initiative to quantify BMP effectiveness. Why bother doing this? Well, you know, at a very basic level, all of our public agencies are spending a lot of public dollars on BMP implementation to solve water quality problems. So we hope. So there is a general sense of obligation to the public to truly prove or determine whether or not the things we're spending an awful lot of public money on are in fact going to solve the problem or all are solving the problem. That's sort of a high level nutshell idea. Why would we bother? Why is a regional BMP monitoring network a good idea to tackle this problem? Well, there are a whole lot of challenges with field monitoring of BMPs. It's really expensive. What you find out there right now are a lot of one-off studies on BMP effectiveness, and that's very expensive to do. And in Southern California, especially where it doesn't rain very often, it's going to take years and years and years to get a statistically viable data set. I really appreciated Wynn and Hannah's talk just now, that I managed to come right in at exactly the right time, because you all touched on a lot of lack of standardization. Well, I've been doing BMP monitoring since I was in grad school, and that I just realized was 21 years ago that I graduated. So, which means it's even longer than that. There are no standards for BMP monitoring that are out there. There are guidance documents, there are best practice documents, but there are no standards. Dan, blue screen of death. I'll keep talking. Do we have a SCORP person to get Dan? Thanks, Leah. But to keep you all on track, I'll just keep talking. So I am currently on an ASTM committee that has just started in the past year to start to develop standards for BMP monitoring. But I will also tell you that the prime motivation behind that is for proprietary devices testing, which is not the same as all the public agencies that are building bioretention facilities or dry wells or detention basins for managing pollutants. So there is a slightly different incentive behind that ASTM committee. Anyway, this lack of standards means when you have all these one-off studies, it's really hard to collate those results. So the idea behind regional monitoring, of course, is that we all get on the same page doing the same thing all the time. And that's going to enable us to generate really robust data sets in a more cost-effective manner and a more time-efficient manner, we hope, anyway. So from a field monitoring standpoint, there are lots of good reasons for working together. One of the outcomes that we're hoping to look at or support is our BMP design manuals. So how many of you feel like you're familiar with the technical process of how the technical steps you go through to design a BMP? All right, so let me tell you about this. There are also no standards for designing BMPs. Every jurisdiction, almost every jurisdiction within California has its own manual. Across the US, it's usually state by state, and then the DOTs often have their own manuals as well. And most of them are written as, "Ooh, I read this over here. And that one was based on research over there and research over there. And that piece sounds good, and that piece sounds good, and that piece sounds good. So I'm going to put them together into my manual." And so you have a wide variation of the design process. We have very little field validation of effectiveness, of what even the elements of your BMP design and whether or not they're appropriate for Southern California. The vast majority of BMP research, field research, has been done in temperate zones, East Coast mostly. And I'm pretty sure, and I come from the East Coast, right? I know a lot about those designs, and I'm like, not so sure that's appropriate for us here in California now. So what we would really like to do is move towards evidence-based design approaches that are appropriate for, well, with the SMC for Southern California. So there's our premise, a lot of our premise for our regional monitoring network. There we go. Okay, so at a very high level, there are 3 goals for this regional monitoring network. We want to leverage resources across the SMC to answer shared questions, questions about BMP performance and behavior. We want to do it in a coordinated manner so we can pull all those results together and ultimately lead to robust decision-making generated from robust data. Those shared research questions, those initial research questions that we're currently working on with the regional monitoring network came out as in sort of 2 categories of inquiry. We took our general management concerns about BMP's effectiveness and maintenance and translated them into monitoring questions for which we can collect quantitative data in the field to answer the questions. So the questions became, to what extent does a BMP reduce the discharge of contaminants? And what's the influence of maintenance or lack thereof on the actual functions of the BMP, how it's removing contaminants? I'm just going to focus on the BMP effectiveness question because today, because you guys are talking a lot about microplastics, and that's where that fits in. Our BMP effectiveness question, we have also narrowed down the scope to look at a single type of BMP. And that single type of BMP is what's called a flow-through or partial capture biofilter or biofiltration system. So on the left, here's an example of a flow-through biofilter. What it means technically is that you have a bowl in your landscape, and that bowl is filled with an engineered media. We can design that media to target specific pollutants or flow control to a certain extent. You have runoff, untreated runoff that comes into the BMP. It ponds on the surface. That's terminal language of BMP. So you get standing water on the surface of the BMP. The only way out is for it to flow vertically through that media where it gets treated through filtration. And flow through or partial capture means that there is a reverse drain at the bottom of that BMP. So water after it's been treated or runoff after it's been treated is then captured in that pipe and discharged out of the BMP. And that means we can sample it. So what we are focused on right now are not BMPs that are infiltrating into the ground, but BMPs that are treating water and re-releasing it and releasing it downstream somewhere. Here's a range of what they could look like in practice. These are all BMPs that are being monitored as part of our regional monitoring network. These all come from the same design process on paper. How they are evidenced in real life comes out very differently depending on site-specific conditions. So what do? We use automatic samplers to capture runoff coming into the BMP, so we collect water quality samples coming into the BMP, and we measure the flow coming into the BMP. We collect water quality samples coming out, and the flow coming out. and then analyzed for a suite of contaminants. The SMC's priority contaminants were fecal indicator bacteria, nutrients, sediments, heavy metals. And now through a grant from the Ocean Protection Council and California Sea Grant, we've been able to add microplastics to that suite of analyses. Now, because of the cost of microplastics analyses, which I know you all are familiar with, we have a limited number of storms and BMPs that we can actually collect these samples from. But because we're leveraging the resources of the BMP monitoring network, the vast majority of this grant goes towards the analyses. Like we don't have, the grant doesn't need to pay for the data collection. The field work part of it. So which is a huge advantage to all of us. All right, so anyway, we're leveraging this network. The contract has been awarded. As of last week, the SMC was like, yep, we're good to go. We're getting everybody's site set up. We'll do some training in January for the field collection part of it. But I don't have a lot more to share on the microplastics initiative today, other than to tell you the objectives of the study are listed here. But there are a couple things we're gonna look for. One is all the BMPs that are being monitored have been there for a while. None of them are brand new. 2 of them were installed last year or earlier this year. So maybe we won't look at those ones. But of the suite of sites that we have available to us, most of them have been around for a while. If we go in and just collect samples of that engineered media, that filtration media that's in there, we can look at what microplastics are already there. We can also relate that to characteristics of the media. Right, and so if we find some BMPs that have a lot of microplastics captured in them, it's not just because they had a higher loading, maybe it's because the design of that media was really effective for capturing microplastics. And that would be about the particle and pore size distribution of that media. How big are the holes where the microplastics can get trapped? Because that is a design parameter in those jurisdictional manuals that I can control to some extent as an engineer. And then of course, we want to, so there's an assessment, like a dry weather assessment of what's already in there. And then of course, there's wet weather sampling plan for analyzing, quantifying microplastics loadings to the BMPs. And where possible, we will also measure what's coming out of the BMPs. The qualifier on that is that, I know you guys know, it takes a lot of water to sample for microplastics. You have to filter a lot of water. And, fortunately for us, a lot of our BMPs work really, really well, which means that even though there's that underdrain, there's a lot less water that typically discharges out of the BMPs because that filter media will hold on to it. And so, but this here is about assessing our sites for having enough water to filter to justify the cost of the analyses. Are there any questions on that? That's what I have to share about microplastics.
I actually do have a question.
Sure.
And thank you. Does the engineered media get saturated with microplastics?
Nobody knows.
Oh, okay.
And then
what do you do with it? Do you take it out and clean it or?
So when I was talking to the SMC about this yesterday, I got a whole bunch of sideline like, hey, here's a great additional study. How do you separate microplastics from the filtration media? And we could do this, and this. So if you'd like to listen, we can have that conversation separately. But there are some ideas out there about how you would separate it. But one of the questions, a very, very valid question is, how long would the media last?
Yeah.
But remember, in my world, so I'm a BMP researcher. To me, microplastics is just another contaminant. My BMP is trying to manage heavy metals, particulate, like sediments, phosphorus, nitrogen. You're competing with a whole lot of you're competing with and trying to balance pollutant removal for a whole suite of contaminants from a single passively operated system. There are no valves or bells or whistles on how you operate the system most of the time. There are things we can do, but California doesn't seem to be doing that yet. We'll get there. So the question of how when do you get saturated with microplastics? You're not just saturated with microplastics. There's other stuff in there that's going to clog up the spaces as well.
Okay.
That makes sense?
Yeah, so what happens when it's saturated in general? I mean,
yeah, so
people take it out.
Yeah, I mean, ultimately, you replace the media. What you do with it depends on the state. Sometimes there are, most often it just goes to a landfill. Sometimes there are requirements for hazardous substances testing, doesn't usually get there, but so most of the time it goes to a landfill. There are things you can do to extend the life of your BMP. Particulate matter should get caught in the top. So really good practice is every few years you have to go in and remove the top layers of media and refresh it. In practice, it probably doesn't happen very often, but it's a feasible practice. Thank you. Where do I need to end on time, Nick?
3:45.
Oh, well, 3:45, you're giving me the whole time. Thanks, Karen.
40 minutes, 5 minutes.
I will try not to take the whole time, but I'm happy to answer your questions. I want to spend the last few minutes talking about tools for standardizing data processing. You guys set me up really well. Thanks. I appreciate that. So in light of this lack of standards, it turns out it's not just that there are lack of standards. A lot of the calculations that happen between the raw data that comes off your instruments and the final data that you need to evaluate performance, there are loads of steps in between there. And it turns out a lot of those steps aren't documented anywhere. And they're really just up to the data analysts to know what they're doing. Which I took for granted until we put this regional monitoring network together. So there are a few big pieces that we've pulled together to try to ensure consistency, establish and ensure consistency across our regional monitoring network on how data are collected, of course, and how those data are being processed and analyzed. So most common, which you guys would all be familiar with, is establishing a detailed work plan and a quality assurance project plan. So we've done all that. What I want to focus on for a couple of minutes here, my last few minutes, is the analysis protocols and these data processing tools. All right, so when we do field monitoring for BMP, we install all sorts of sensors that during both wet and dry weather will generate thousands of lines of data per storm. So when you're doing BMP monitoring, you're collecting data, if you're doing it when I'm involved, on 1 to 5 minute intervals, right? It's a lot of lines of code, lines of data. So there's an awful lot of steps for cleaning that data, doing your quality assurance checks on that data, and then trying to consolidate them and transform them into actionable performance information. Use intelligence that you can use to inform decision-making and evaluate your BMPs. This is the parts where lots of subjective decisions are made and lots of manual processing occurs. So we decided that we wanted to try to, partly to streamline that process to help out our partners, but also to ensure that that consistency of data processing. So we have published so far 4 calculators and 2 web apps. These are publicly available. I'll give you the QR code at the end. One set of calculators processes rainfall and flow data. Another set of calculators are related to water quality data. And this is our flow weighting and event mean concentration calculator. That one has a really long name, but that's what it does. So I'll give you a couple of slides on what those do. The raw data that comes off your rain gauge is called a hyeta graph. Those are those vertical lines, minute by minute, of the amount of the rainfall that was accumulated. That's what a tipping bucket or any kind of rain gauge generates, that minute by minute, how much rainfall was there. Your flow data, it doesn't come off a sensor as flow. There is no meter that actually measures flow directly. You have a combination of instruments that are used. So your Flow data comes from a reading of water depth or water velocity and goes through a series of calculations before you get flow, but that's what it looks like. Pretty messy data. So what our calculator does is it takes that time series data and consolidates it into the very typical metrics that help set the context for or directly contribute to performance evaluation. So when it comes to rainfall, things like the total rainfall and the rainfall intensity, or maybe the peak rainfall intensity over a 5 or 10 minute period might be influencing factors on how your BMP performed. These sound like really simple calculations. And on one hand, they are simple calculations. But on the other hand, everybody has a slightly different interpretation of what a peak 5 minute intensity means or a peak 10 minute intensity means. And how you actually do the steps of the calculation can make a difference. So we've created a standard approach that can work with multiple different types of rainfall data. And it takes about a minute to generate all your data, and you can process a month of data at a time. The flow data, so flow data, your time series of flow is called a hydrograph. So hydrographs are really important. Flow data is really important for pollutant load mass balances. You need the total volume of water that was generated. The total volume of water is the integral of that squiggly line. It's the area under that curve, right? So, and it turns out there's a lot of subjective decision-making on how you chop that hydrograph to get your total volume, and the math you use to sum it all up, not written down anywhere. So we came up with an agreed upon method, wrote it down, it's in the calculator, and so now we have a standardized approach for getting your total runoff volume, direct impact on mass load calculations, how the peak flow rates, which are important for evaluating lots of different aspects of performance, and the duration of the hydrograph. Simple, simple, and then it outputs directly for our SNC formats. Sorry, seems super simple, but now it's streamlined. So the second web app with 2 calculators is our flow weighting and event mean concentration calculator. Pollutant concentrations and flows change dynamically over the course of a storm event. An event mean concentration, are you all familiar with that term? Or what's our comfort level with that term? All right, so pollutant concentrations and flows are quite dynamic over the course of a storm event. An event mean concentration is a single number that brings together in a meaningful way that dynamic concentration so that we can get a load. So when you multiply your event mean concentration by the total volume from that hydrograph, you get your pollutant load. Very different if we did an arithmetic average. If you took a sample, each one of those was a sample at a different time, and you just averaged those together, that would not represent your pollutant load because the pollutant load, the concentrations are increasing, decreasing over the course of the storm event, as are your flows. So flow weighted event mean concentration means that you have a weighted average concentration. So you account for the highs and lows of that pollutant and flow variability into a single number that represents your whole storm event. Very common practice in BMP. This is the gold star or the gold standard for BMP monitoring, and yet, or BMP evaluation, and yet no one ever wrote down how to do those calculations. So we did it. What does it mean practically? Here's an automatic sampler. It can generate a whole lot of, you can program it to do different things, but in one common variation, you have up to 24 individual bottles in that carousel from your sampler, and they get filled up individually. What our calculator does is gives you the instructions on the ratios of each bottle to combine to get your event mean concentration. This is a process that has never been written down before. And when you ask everybody how to do it, they're like, I couldn't describe to you what I do. And I might do it a little differently every single time. Not anymore. So with our calculator, your input is your flow data from your that you've been measuring, the times that you collected your samples, And what it spits out is the instructions for your lab. This will save your technical folks literally hours of calculation. And it also will avoid mistakes that are made that are really common. So finally, so to me, we have a manuscript that's out on that one. That's the one I'm bringing to ASTM to standardize and formalize, because that one was a big one to me personally. Anyway, finally, coming back to our regional monitoring program and our coordination, we have an information management plan that has developed a data structure, established terminology. We've developed some data portals for submission of all the information on how your BMP was designed and built and all your monitoring data. But I'm not going to go into the details of any of that. And here we go. So where are we now? We've got lots of, it's the wet season, right? So we're deep into it, more or less doubling the number of BMPs that were monitored last year, that will be monitored this year compared to last year. It's been a great effort. We have lots more calculators that we'd like to develop to help streamline the process and help our agencies. This is an SMC initiative, but that doesn't mean it's limited. You know, we absolutely, the way that the organization works is that, you know, everything is done through a working group and through consensus, so everybody's bought in. If you don't like it, you don't have to participate. If you want to participate, each agency that's doing monitoring pays for their field operations. The SMC pays for the oversight, the data management, all the data analysis. So there's no reason that other agencies couldn't join in or other folks couldn't join in. If you're interested in the calculators, that QR code gets you an email because you don't want that calculator on your phone. You want it on your computer. And also there are, for the rainfall one, there's an API. So the rainfall one, there's an API, and for the flow weighting and EMC calculator, there's a GitHub link. So you can incorporate these codes into your own bespoke programs. Here we go. Wow, that really, I got 2 minutes to speak.
Right. Yeah, I wanted to bring, thank you. I want to bring this up because I mean, I think there's some applicability to what, you know, the study that you're doing in Monterey Bay, especially with the upstream rivers and looking at the wet weather events. But I also, SMC is coming up on, they do a research agenda every 5 years. And I wouldn't be surprised if microplastics came up as a topic of interest for the stormwater discharges, seeing the writing on the wall. So I think that they're going to build that connection sooner rather than later, because they're just about to kind of re-up that research agenda coming, I think, next year around this time.
Yep.
So, yeah. Any questions for Elizabeth last minute?
Well, Nick, and I just want to thank Elizabeth for the presentation, and I just want to share with the council members that this is really important work for a number of different reasons. Very valuable work as well. And Elizabeth is correct. The way that you know, that the monitoring methodology is done, it varies from program to program. No two programs are doing it identically the same. And so when you go to look and compare data and conditions, whether it's conditions of streams or how BMPs are performing, it's hard to make that comparison when no two programs are doing things the same. So I think this represents a way to standardize the way data is being collected so that we can be able to do that comparison. That's really important. The other reason this is really important is a lot of money is being invested in designing, building these types of BMPs, because these are really, this is how stormwater agencies are going to meet compliance targets. This is the method to get to compliance targets in wet weather. Constructing these BMPs, a lot of these BMPs are being built with public funds and being you know, installed in public right of way. If we don't understand how these BMPs are performing, if we're not able to measure and quantify whether or not they're actually meeting the regulatory compliance targets that they were designed to help meet, then I'm not sure that's a really great investment. So this offers up a way for us to be able to do that in a standardized, scientifically vetted way. So just want to thank Elizabeth and her team for leading the charge on this work.
Thanks for your support. Yeah, the SNC has been pretty amazing with this one, so.
Super important.
I agree with everything you said. What's the mechanism for exporting this beyond the SMC?
I think that's something that the council actually should think about, and this could be I think this is right in the council's wheelhouse. Come up with ways to promote how these are wonderful tools, but if no one is using them, how valuable are they, right? So I think that's one of the reasons why I was interested in hoping that Elizabeth could share this with the council, because I think that's a great question, Steve. I would hope that the council could play a role in that.
I'll let Anna get started, but we can I, Amanda, and Gerhard have a meeting about just to talk about that exact thing about how SMC is spelled across the agency and across the state, and how we can better integrate that broadly. So that'll be coming. But I agree, the council is a great place for that. Thanks, Elizabeth.
Cool. Thanks, everyone. Drop me a line.
Right.
It's been a long day. Y'all didn't have a break, so while we're transitioning, I invite you to stand up, reach for the stars, touch your toes, whatever you need to do. For those that, trust me, it feels real good. For those that don't know me, my name is Anna Holder. I'm an environmental scientist at the California State Water Resources Control Board. I'm going to be leading our presentation today, but I just want to acknowledge that our safety workgroup co-chair, Jay Davis, is online. We often do tag team presentations. Hi, Jay. And so he might chime in as needed. No, you or me. Okay, great. It's been about a year since the safety workgroup, or the STU, came to chat with y'all. And I'm going to focus our conversation on the program realignment update. We just literally on Monday wrapped up a key component of the San Diego region realignment, and then looking ahead for our long-term monitoring priorities over the next 5-10 years and beyond. And kind of give you a heads up on how the council and those partners that we all know about, and maybe some we don't, can engage and participate and collaborate in the future. So for those that don't know, it's kind of confusing. There's SWAMP, the Surface Water Ambient Monitoring Program. Our bioaccumulation monitoring program is at the state board, and we fund and coordinate the generation of bioaccumulation data in water bodies throughout the state. That's our task. That's what the legislature told us to do. The safety work group is, I like to think of it as the bioaccumulation monitoring program is like the back end, and SWAMP and the STU is the front end. So this is how we engage with the public, how we share information, data, and resources, and really coordinate and collaborate amongst the bioaccumulation community with experts and communities that are impacted. The program and the STU have been doing its thing for quite some time. The point is not for you to read all the things on this slide, but just to highlight that the majority of our monitoring has taken place in lakes and reservoirs. So that's kind of like the dark blue bars, with some coastal monitoring and periodic lake and reservoir monitoring. Particularly with a long-term Bass Lake monitoring study that we wrapped up this year as well. Some things coming up. We often report on the data that we've collected and the reports that are coming out. The monitoring year is on the left. The kind of water body element is in the middle, and the anticipated report is on the right. You'll notice that there's a couple of asterisks on years 2020, Through this year, we're just waiting on organics data from our lab, and then we'll wrap up those reports and share them. So I started in this role in 2020. My first day in this position was the first day of lockdown. I'll never forget it. And when I started, we kind of wanted to take a look back at all of the amazing things that the program, and at that time, the Bioaccumulation Oversight Group, or BOG, was doing and had done since the beginning, and really identify what's been working and what needs a little bit more attention. And we kind of, we did. We identified 3 pillars that needed a little bit more love. Those are building stronger relationships with our tribal government partners and communities that are impacted by the consumption of fish and shellfish with pollutants that bioaccumulate. Building stronger connections between the water boards. There's 10 different state agencies. As you might have guessed, sometimes we don't talk to each other as much as we'd like to or should. Surprise. And then really fill in data and information gaps, particularly for those that consume fish and shellfish for subsistence, tribal, and cultural purposes. The program, the legislature created the program with a focus on recreation. So there's a big gap there for those that depend on fish and shellfish for their livelihoods. As you might think, kind of integral to this work is us really thinking about how do we do our part to operationalize equity into our program? How do we make different choices, center different voices, make different decisions to really make sure that the decisions we make and the outcomes that we achieve are equitable? So we invented this thing that we call the realignment. It's a 3-year process that we're using to kind of center and focus on each water board region. There are 9 regions. The first year is really coming together and identifying the data and information gaps for the tribal and community-based organization partners that participate. Basically saying, hey, where would you like data to come from? What things should we sample? What pollutants are of most concern to you and your communities? We make a monitoring plan. The second year, the Bioaccumulation Monitoring Program pays for the monitoring and analysis and conducts the monitoring, while we also continue meeting to kind of identify how can we do better to make sure the people that are fishing and eating fish get the data and information they need to make informed decisions. I think about our website. We're talking about the web revamps. My father, my brother, my uncles, my aunties that go fishing, they're not gonna go on my website and read the 75-page report about bioaccumulation, blah, 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 right? They don't have time for that. How do we get the data and information in their hands to make powerful and informed decisions for eating fish and shellfish safely? And then the last year, data hopefully is starting to come in. So we start to share that. I'll share some preliminary data with you today. And also thinking about, this is a 3-year process. My goal is not to end the relationships after 3 years. How do we continue moving forward in partnership to achieve our common goals in the bioaccumulation community? So we started in the San Diego region. Peter and Ray were part of this process in the beginning, and we met 7 times with the advisory committee. We created a monitoring plan and did that monitoring. We developed a communication and outreach plan that was requested by the advisory committee to kind of outline the actions that the Bioaccumulation Monitoring Program and the Safety Workgroup will take to improve our communication and outreach over time. And we have, for a lot of the conversations, some ideas and feedback and thoughts really didn't fit in either of those 2 documents. But I wanted to capture them and document them to make sure we can kind of keep them in our minds moving forward as we continue to make decisions. And we're working on a data report right now. Everything's available on our website, and there will be more on a GitHub that I'll show later. The San Diego Advisory Committee was made up of tribal and community-based organizations with invited guests from this council, as well as the partners that we work with to do the thing every year, from Fish and Wildlife to Department of Public Health, OEHA, Moss Landing Marine Labs are the folks we contract with to collect and analyze some of the data. SFDI, and a little bit of the US Forest Service. The advisory committee members are on the left. Those are the folks that had the decision-making power. They could say, these are the priorities for monitoring, thou shalt monitor this thing. Everyone else was there to listen, to provide their expertise and feedback, and to learn together. This is one of our final maps. All of the points on the map were highlighted as important to one or more members of the advisory committee. And the red dots are those that we weren't unable to sample strictly because of resource limitations. The blue dots were those that we were able to sample, and analysis is underway currently. The monitoring and analysis work plan really kind of documents and details the types of conversations that we had and how the committee prioritized and made the decisions of these 10 water bodies we're going to sample now. The Regional Water Board has been kind of a equal co-partner in this work. It would not be here without Chad Laughlin. Shout out to Region 9 and their great work and their funding for the analyses. And they have committed to kind of adding the red points and the blue points to their monitoring moving forward. So we're already changing how we're working. We also talked about, okay, we got the samples. We know we're catching fish, some shellfish. What do you want to analyze? And how do we do that differently? For those that aren't aware, but maybe go fishing and you go out on a water body, you might see a sign from OEHA with pictures of fish in red, orange, yellow, and green, kind of showing you which fish are safer to eat at that water body. To make those signs and to be consistent, OEHA has to make certain assumptions and requires certain types of analysis and data. One of them being they analyze fish, skin off fish fillets. A big conversation that we had at the advisory committee is that sort of consumption, that assumption of how people consume fish does not align with the lived experiences of many of these communities. Folks eat different parts of the fish. They make fish soup and use the whole body, right? And so they were really, really wanting to know what a whole body analysis looks like on a fish and how those data differ. And so there's a graphic on the right of San Diego Bay with the different fish that were collected on the left, the levels of mercury on the x-axis. And you'll notice that the spotted sampus at the top is a skin off fillet. Everything else is a whole body sample, which is very different from how what OEHA uses in their fish advisories. So these data won't be able to be used by OEHA. That wasn't our priority here. Our priority was to collect data that was important to community. So we also talked about the analyte suite that's normal for the bioaccumulation monitoring program. Mercury, selenium, PCBs, they said, yeah, all of that. And we want to know about PFAS, and we want to know about cyanotoxins in tissue. We decided to collect water samples for logistical reasons. Microplastics also came up as a priority, but it was grouped in the, if we had all the money in the world, we would do this right now. But there's still some uncertainty around, we were talking about this 2 years ago. A lot has happened in microplastics since then. But it's something that's top of mind for tribes and communities that I've been speaking with in San Diego region and beyond. So we wrapped up San Diego. We're waiting on data. Chad Laughlin and I, San Diego region, are co-authoring the data report on GitHub. So that'll be out as soon as we can get it. Next up is San Francisco, and we're starting as soon as possible next year. One of the big lessons that we learned is, we knew intellectually, but the advisory committee structure, you know, having X number of people with alternates and requiring that those people show up at all of these meetings doesn't work for folks. They're busy doing all sorts of other important work. And that we got a lot done in the San Diego region, but we could have had more if we were able to hear more voices over time. So in San Francisco, we're still having the same three-year process, but we're going to be opening it up to a workshop style feedback solicitation. So it'll still be limited to tribal government representatives and representatives from community-based organizations, but through a series of workshops where people can come if they're available and don't come if they aren't. And that's how we're going to solicit feedback and make decisions moving forward. Contracts are contracting, so I don't have a start date for the first workshop location, but we'll be announcing that through the safety work group email list as soon as it's known. Maybe. So if you're in the San Francisco region, and note, not just the San Francisco Bay, but the San Francisco region, and you're interested, want to know more, you want to stay updated on this, please send me an email and I'll loop you in as things progress so you're aware of workshops, things like that. And we're going to start that process, focus on San Francisco, and mention, you know, only 30% of the programmatic budget is going to the realignment process. We're still going to be doing our statewide monitoring on top of this. And then I will be following up with tribes and regional coordinators in 2025 to start thinking about which region is ready to come next. So yeah, if you're interested in San Francisco, particularly if you're a representative of a tribal government or a community-based organization, and you just want to chat and know more, please reach out to me. I'd love to talk to you. And the request for the council is to spread this broadly so that people know what's coming. Now I'm going to switch gears. I talked about the realignment. I kind of gave you an overview of the program in general. As you might have seen on that table, we're wrapping up the 10-year lake study. We finished monitoring for that this year. In 2024, we're wrapping up the coast, and we're at this sweet spot where we can pivot, we can change our minds and think about what the priorities for the program and the safety work group are for the next 5, 10, 20 years. So again, I invented a process, evidently that's my thing, called the long-term monitoring priorities assessment. And it's really an opportunity for me to hear from you. I want to hear from our bioaccumulation monitoring community about what your priorities are. Happy to say I actually had a meeting this morning with folks from SWIRP about the Bight and figuring out how to loop them into this process. And I'm particularly interested in hearing from, again, tribal governments and community-based organizations. And really talk about how we can most effectively use our very limited resources. The program budget has not changed for 15 years, but costs have. So that means it's not if we have to make hard decisions, it's which hard decisions are we going to make. And I don't want to make that without hearing from folks. So again, all of this great work has happened. We're at the end of 2023. Oh my gosh, how did we get here? What day is it? And thinking about tentative monitoring plans moving forward. Jay and I have thought about some ideas. We've tossed things around, but everything is tentative with the lowercase t. And by the end of this long-term monitoring process, I'd really like some clear vision, our ability to generate the monitoring plans, submit for permits, and start doing the work. So for those that aren't aware of the monitoring that we have been doing for quite some time, here's just kind of like a geographic representation of the lakes and reservoirs that we've been monitoring, coastal areas, and rivers and streams. just bear with me for the next couple of slides. We're gonna walk through this. Lake and reservoir monitoring occurs in odd years for a 10-year cycle. Coastal areas, 3 regions over 2 years, approximately every 10 years, and in partnership with the Bight, that's one of our close partners for the coastal area. And then rivers and streams, we did really robust monitoring about 10 years ago, and we've done some very specific monitoring in Region 5, literally very specific, only 6 sites because that's all we could afford last year. Here is a kind of big picture view of the analyte suites that we generally use at the different areas. You can see that mercury, selenium, and PCBs are kind of our go-to standards. We pretty much analyze for mercury, selenium everywhere, and then all the other things, it depends if we have the money or the requests or whatever. Algal toxins has been very limited in rivers and streams, but again, through the realignment process and conversations that I'm having with tribes and other partners throughout the state, it's of great concern as harmful algal blooms are becoming more and more frequent throughout the state. Our feedback process, this is really a reflection over the past couple of years that I've witnessed. And I'm sure Jay can speak to process from long before that. But again, bear with me. Long-term monitoring plans were developed 10 or so years ago, and we've kind of just been chipping away at them. The July or August prior to the monitoring, we kind of talk about the draft monitoring plan, looking at that long-term plan and saying, what updates do we need? What requests do people have? Making revisions as needed. Calling for requests, particularly from the regional water boards and OEHA, again, our partner in developing those fish advisories. By the end of the year, we finalize the plan, submit for permits, and we start to monitor from April to October the following year. Now, as I mentioned, we will be making difficult decisions. So when we do, some things to keep in mind is compared to the first year, are significantly reduced in overall stagnant budget, but costs are increasing. I think most importantly for me and the bioaccumulation monitoring program and the safety work group is, again, how do we operationalize equity? How do we center the needs and voices of those that are most impacted by pollution in fish and shellfish? Of course, our water board priorities, and then tribe, agency, and organizational partners. Mercury has been a heavy hitter for quite some time. It's not the only player in the game. We're hearing about PFAS and microplastics and harmful algal blooms and all the other things. So we want to keep those in mind as we move forward. And then really strengthening and building our partnerships to build on each other's efforts so that all of our dollars go further and we still get high quality usable data and information to make informed decisions. So as I've been playing in the garden or doing dishes, I'm thinking about, all right, if it were just up to me, what are some things that we might change? None of this is finalized. This is just what's bopping around in my head, and I'm using it to solicit feedback. Lakes, reservoirs, and coastal areas have been dependable. People go there often. A lot of folks need and use that data on a daily or weekly basis if you're a fisherman. Rivers and streams, we can only get there once every 10 years. It is the most expensive water body type to monitor, just to get the literal humans in the river to catch the fish and do the thing. It costs a lot of money. I don't know if our return on investment is high enough, just thinking about that on my own. Analytes, like I mentioned, we know a lot about mercury. We've got a robust data set on mercury. We also know it's probably not going anywhere or it's not improving very quickly. Do we need to prioritize mercury in the same way that we have been? Do we monitor it at every site, or maybe just those sites that haven't been monitored yet, and instead prioritize PFAS, microplastics, PCBs, something else that's not on this list. I don't know. And then I think one of the biggest things is I'd like to change how we solicit feedback and who we hear from. So we're going to make another 5 to 10 year monitoring strategy. We need to submit for permits about a year before we go out in the field. That's just what we got to do. So by March, we want to submit as broad of a collection permit as we possibly can, which means we need a general monitoring plan and an idea of the species. If we could collect everything we wanted, what would it be? I also like to make more consistent our deadlines for presenting our draft monitoring plan every year, the call for requests so people know on a rhythm what to expect and how to solicit feedback. And we're still gonna call for requests from the regional boards and OEHA, but I really wanna make more space for, again, our tribal government partners, the partners that do their own bioaccumulation monitoring, where we can kind of leverage and partner on efforts, and other community-based organizations that represent folks that consume fish and shellfish for subsistence. Those will be due September 1st. The request will be due. We wrap up finalize the monitoring plan by the end of the year. And then we present the final plan in January or at the start of the year. And really how we monitor and when we monitor is up to the weather. It's most effective to electrofish, but there are lots of I think US EPA or NOAA requirements about how to do that while protecting biological uses and life. And so if the water's too hot or salty, we can't do it. So instead of monitoring from April to October, we're noticing that we're monitoring earlier and maybe going a little bit later. And then wash, rinse, repeat. So for this long-term monitoring priorities assessment, I've asked and required our regional board partners to complete a template that makes them think about their monitoring priorities while thinking about their regional board priorities, their tribal beneficial use designation process, their own monitoring priorities, and lots of other things. And by the end of this, I'd really like to get a better understanding, again, lowercase t tentative, long-term monitoring plan, but then have uppercase tentative 5-year plan. And then we need to know and submit permits for 2025 and ideally 2026 by like May of this year at the latest. Cool. So this is an example of the template that, again, the water boards partners, the regional boards and Division of Water Quality partners sent to me by November 30th. I was super impressed by that. Here are all of the topics that I asked them to think about. Sometimes it didn't necessarily fit, so not everyone completed everything. That's not the point. Early on last year, when I started thinking about this process and asking folks that participate in the safety work group, what would be helpful for you as you start like noodling amongst yourselves and thinking in your own gardens or whatever, how that information would be helpful. And so I created a more generalized template that is optional for tribal, other agency and organization partners, but it's there as a resource if folks want to complete it. I also heard and learned from the realignment process that some folks don't necessarily want to give feedback when their name's attached to it. They don't feel comfortable or other reasons, but they still want to solicit feedback and they still want to be part of the conversation. So this is a link to a monitoring priority survey that has 10 questions, 4 required. They're multiple choice, so if you only have 5 minutes, it'll be less 2 minutes. You can just complete the required questions and move on with your day, but if you want to take more time and give more feedback and information, then there's space for that as well. The required questions are on the slide. What type of affiliation are you with? Tribe, state agency, something else? There's 7 options, I think, including an other, and you pick one. Generally speaking, what water body types would you like to see prioritized? So here, there's a list of lake and reservoirs, coastal areas, rivers and streams, and you have to pick 2. So if we're gonna cut something, what are you gonna cut? What type of species would you like to see? There's 3 options here: fish, shellfish, other. Again, if we can't sample one thing, which, by the way, our program has never been funded adequately to monitor shellfish strategically and robustly throughout the state. But maybe if everyone says, we don't care about fish anymore, we just want shellfish, I want to know that. And then which pollutants or contaminants are most important to you? There's a list of 10, and you get to pick 5. So all you're going to do is submit the required questions. Those are the questions you're going to be answering. And then underneath the 3 bottom questions is a kind of like open comment area where you could say lakes and reservoirs, but this is my favorite lake of all time. Please monitor this one, or you monitor this one enough, leave it alone. Any other feedback is open there. We also, I literally want to hear voices from different folks. So we've added, usually the safety work group meets quarterly. We've added lots more meetings between November, we've already had a couple, and March. And so here are the ones coming up. Next week, we're gonna hear from the Los Angeles region, Lahontan region, and San Diego region, and they're gonna be presenting their templates. Everyone's gonna have about 20 minutes just to kind of like share, and we can discuss. In January, we're hearing from everyone else. The agendas are already posted, and we're using Zoom, so folks need to register, and that enables individuals to go and register now and download all of the calendar invites that your heart can handle, and then you don't have to think about it for the rest of the year. At the end of January and February, we're going to hear from tribe, agency, and other community-based organization partners. OEHA is already on the books for the 31st. I'm going to hear back from our squirt partners soonish about which date will work for them. And as soon as I hear from folks, probably a couple weeks before January 31st, I'll publish those agendas. In March, we're going to start synthesizing what we're hearing. For me, I'm really looking for common threads and trends amongst all the folks that choose to share with us, including that survey that can be included or not. And by April, we're going to be making our decisions and have those monitoring plans for definitely 2025, hopefully an idea for 2026, and then a longer term strategy for the program and the safety work group. April, July, and October are regular stew meetings. So we'll just get to hang out in the swampy stew and talk about what's happening with our coast monitoring. So I mentioned that there was a template available for tribes, agencies, and community-based organizations. That's just a resource. You don't have to complete it. Basically, by January 1st, I just want to hear from folks on if they're interested in presenting or sharing their thoughts and what that looks like for them, so I can get them on an agenda if that's appropriate. And then for folks that, you know, there's a phrase for public speaking. It's like folks would rather be in the casket than giving the eulogy. Maybe if you're not a public speaker, but you still want to provide feedback, you can complete that survey by March 1st, and we'll still be able to incorporate your thoughts into the process. And then anyone and everyone can visit our meetings page and again, just spend a couple minutes registering. It's a lot of things to register for. I know it's a pain in the butt because I created the meetings. But please do that. And then, even if you forget, but you want to join that day, you can register that day and you'll be able to join. So why am I talking to you? Well, one, the safety work group is a work group of the council. And I'd really love your help identifying and connecting with maybe tribal government partners that are interested or conducting their own monitoring, community-based organizations that are interested in anyone that thinks about, loves, hates accumulation monitoring. I want to connect with them. And you all have amazing networks. So please share these slides or my contact information broadly. A big limitation, and I think when I presented back in August of last year, this last bullet was, I think, identical. For folks that aren't funded through the surface water ambient monitoring program, they might want to monitor, particularly tribal governments, but there's not a ton of funding available. So one thing that I thought could be helpful, potentially a list developed by the equity work group of monitoring funding opportunities for tribes, community-based organizations, but really having a list of opportunities for water quality monitoring that folks can go to and lean on as they develop their own monitoring. And I think that's it.
Thank you. Question for
Anna, thank you. Such important work. So how in San Diego region did you go about successfully engaging tribal governments and community-based organizations? Because it's not as easy as just calling them and they trust you.
Right. So I worked closely with our Office of Public Participation and the regional board to identify community-based organizations. They have their own list. They already have partners. Same with tribal governments. I'm also I'm in the same office as Nick, our tribal coordinator. So we utilize the Native American Heritage Commission, which is another California state agency that keeps a list of California Native American tribes. Tribes can opt in to providing that information, and we have access to that list. And the one thing I'll note is that includes federally and non-federally recognized tribes. Federal recognition is irrelevant to me in terms of engagement and participation in this process. We want to support all California Native American tribes the best we can. For those that don't know, there's close to 200 tribal governments in the state. So it's a lot of folks. So I sent an email to our tribal email list, as well as following our own consultation policy, although these aren't formal consultations according to the legislation, but basically sending letters to tribal leadership, as well as their environmental directors, to all the tribes on that list. And then have just been slowly developing relationships. You mentioned it's not easy. The trust, the big cavernous gap of trust that we need to build back up is tremendous. And so it's something that another reason why, although we're closing the loop on the formal 3-year realignment process, as our office's tribal coordinator, I'm still trying to develop relationship and trust with tribes throughout the state. So we didn't have as much engagement as we would have liked, admittedly, or for those that did say, yes, I want to be part of the realignment process, maybe they weren't able to attend many or all of the realignment meetings. I'm told it's not because of me, it's because they're busy, and so I'm choosing to believe that. But yeah, it's something that I'm always working to improve and learn.
questions. So one for this group specifically related to you have archived samples of the composites you've collected over the years, right? I know this question for you guys, or folks familiar with what it takes to test for microplastics in fish tissue. Would a composite sample work for that? So, I mean, there's a significant amount of resources that they expend just for the fish collection. Like, that's a huge part of the budget that they spend on. They've already spent that. They have these decades worth of fish tissue in
5 years.
Oh, it's just 5 years? Okay,
Yeah.
5 years worth either way to look at. Well, they've already paid for that part. Like, would that be of interest to, you know, maybe build on that kind of analysis or not? Or is it not worth it? I mean, I know that just based on what the knowledge of the science is now.
The samples have already been processed.
They're in freezers.
Are they whole fish or they've already been?
Oh, they've been contaminated, huh? Yeah.
The self-contamination risk is
Too high.
Okay.
Yeah.
Okay.
Yeah, and I mean, just, you know, sitting in the microplastics talks, the amazing talks that y'all gave today, from my programmatic lens, it doesn't sound like it's cost efficient to run microplastics analysis next season. Unless you get a substantially larger budget. But maybe it's a priority that comes up and we have to plan for that and think about that over the next, decade.
Another question, has OES shown interest in looking at the consumption rate information that you gather from the tribes and community-based organizations that you engage with and looking at creating subsistence or culturally based advisories?
I don't want to speak on behalf of OEHA. What I will say is they have been active and clear partners in the realignment and have really been, they've attended every single meeting that we've had with San Diego advisory committee members. They are present and actively engaged to our safety group every meeting, lots of conversations with them in between meetings. I think there is interest, but I anticipate it's a resource limitation on their side too. And it's something that I'm actually, Ray and our OEHA partners at our last realignment meeting on Monday in San Diego, we took a nice little walk around the Tijuana River Estuary Visitor Center. And, one of the conversations was, wow, it's a big problem of closing the gap between the advisories that OEHA generates now and this real need for helping folks consume fish and shellfish safely and according to their cultural practices. I don't think any of us have the solution for that yet, and it's going to take more than one entity to figure it out. But what from my experience is our OEHA partners are open and really trying to work with us to figure out how we fill that gap.
I just want to say that for those in the room and then online also, being part of this project process is that, this wasn't, just kind of a dry check the box formulaic work group. There was real sincere outreach to, the tribes and community groups and stuff like that. And, I really felt like the information that was brought in, and sometimes it was just from somebody who was only able to attend once, but that was listened to and became part of the process. And when you look at that map and what actually is getting monitored and all that type of stuff, the work group made a difference on that. And so like I said, it sounds like they're changing it up a little bit. I think the workshop format may be helpful for Wind Up North. But if you're thinking about, well, I know a community organization that maybe doesn't have a whole lot of capacity or something, tell them about it anyway. And, maybe they'll be able to attend once and provide some important input. And then I was amazed by the turnout of staff. And like I said, just the work put into outreach. And so, yeah.
Thanks, Ray. The other thing I will add is through the realignment process, we have set aside funds to compensate tribal government representatives and community-based organization representatives for their attendance and contributions. It's gonna be a little bit different because it's not an advisory committee structure, it'll be a workshop structure. But we still have the funding and interest to provide those honoraria because I don't want to be another program that extracts information from community for our own benefit. So it's not as much as I'd like, but it's a start.
Did you do your meetings at night?
No, but it's something.
I hear that that's at night, provide childcare.
Yeah.
Provide food.
Yeah, that's definitely something that we're working on getting contracts in place to continue working with our same facilitator. And as we're rethinking and applying the lessons that we've learned and the requests that we've heard from the San Diego process, it's something that I think we'll be implementing next time. Another difference is we plan on having community-based organization only workshops and tribal only workshops, just to give folks that space.
But I think another difficulty that we had in San Diego is it was the height of COVID, so.
Well, sure. Oh, yeah. Okay, that weird thing that happened. Well, at least successful then.
Yeah.
Such a great one. Yeah. I didn't even think about bringing that up. Thanks, Peter. Yes, so many of our meetings were virtual, and it was only this year where we have been able to do in person. And we want to continue offering hybrid opportunities because there's just different kind of energy goodness that happens when you're sitting in a room with people, as you all know, because you've made it here today.
Well, thanks again.
Okay.
Great work. Yeah.
Jay, we've been checking out your pretty face this whole time. Is there anything that I missed that you'd like to add?
Well, yeah, because you don't want to toot your own horn, but I just want to give a shout out to Anna for taking our work in the safety work group and the bioaccumulation program to the next level. And the work that we're doing on engaging with communities and tribes is groundbreaking. We're on the ground implementing a more equity-driven monitoring program and learning a lot as we go. And I think it's very exciting stuff. And Anna's also doing a great job of gathering the input from the agencies as we reach this crossroads in our long-term monitoring design. So a lot of good stuff is happening because Anna joined the team back in 2020. So it's been great working with Anna.
Thanks, Jay. We call ourselves a stew crew, just in case. Yeah, thank you.
Thanks, Anna.
Yeah.
Thanks, Anna.
All right, so I'll go over. Oh, extra. I just want to touch quickly. We've already sent out the whole date. I didn't hear any negative impacts. There were a couple that could be maybe one meeting, but in general, I sent out these whole dates for next year's meetings. And looking at, I heard some feedback that maybe the first and third meetings were better in person hybrid like this meeting because of the timing versus summer and kids getting out of school and then the holidays like now. So unless I hear otherwise, this is going to be our meeting schedule for next year. I heard some different topics. We've been talking about the OH monitoring model and maybe this upcoming spring being right for that. I'm not sure if that's still the case. I'll follow up with Steve and Lorian about that to see if that is still the case or if it's maybe not ripe yet. I also heard some other ideas today about exploring the health report card, how the council could impact bond measure recommendations, the role of recommending methods for adoption, and if so, to whom, and then how the council can build capacity in labs or sampling crews once methods are developed. If you have ideas of a specific topic, I think that the centralized topic tends to work well, or has been working well in the last year or two. So if you guys have a strong feeling towards this topic, please reach out to me. I recognize that over time, you don't do it now, but if you have an idea now that you want to voice that I haven't mentioned, please feel free. I have some action items that I'm gonna follow up.
You asked about the dates. Can you read that topic?
Go ahead.
I can't make April 5th.
Okay.
I understand what you were saying. Other people not.
The only other person that I couldn't make it was on this September 26th.
I can't make it both fast. That doesn't mean you should.
Yeah. I'll be transparent that these are the dates that worked for both Karen and Jen. We haven't had Jen, who has been our co-chair for the last year, because of it, our meetings have conflicted with a different commission that she's on, social commission. So that was it. These dates were selected based on their calendar for next year, which is already booking up. So I appreciate that. Maybe no, I appreciate that. Hopefully, maybe Ken can come in your place potentially as an alternate. But if not, then I understand.
I just press it.
Okay. That's good to know.
And the other one was December 20th. That's the Friday before culture.
That's why it's virtual. Yeah, that's that would hopefully, again, the virtual ones are shorter in nature and all, maybe like an hour and a half, so nothing crazy, recognizing that is very close to the holiday, Christmas holiday. Not hearing, follow up with me if you have other topics I haven't mentioned. I'm gonna look for finalizing our EPA rep to help answer some of those questions that were brought up today. I'm also gonna look at how we adopted the ATS STM method for drinking water, and can we learn from that on the other methods that we looked at. Also gonna engage the National Council on that to see if other states have come into that process. And then resource opportunities on the equity page that Anna brought up. I'm seeing Lauren, your hands up.
Yeah, I was just gonna comment that if Steve can't make it, we should probably not do the OAH monitoring in April.
That's a good point. So that means I need a new topic for April, an in-person meeting from some of you all. So I'll follow up with you all via email. And with that, thanks for everybody for showing up in person, and have a great holidays in the new year. And thanks again for a great 2023. And the recording will be up, and I'll be following up the presenters to see if it's okay to share their PDFs of their presentations with interested people, council and beyond. So thanks again.
Thanks, Nick.
Thanks, Nick.
Thanks, Nick.
Had a drive with you before.